working with a bunch of really, really interesting InfoVis researchers. And then in the last 6 months, I've actually moved back to North America. I'm now at the University of Calgary, starting to sort of build out a lab. And I think my work over the last couple of years, and especially the work going forward, is really trying to focus around this sort of intersection of data and human experience, and trying to understand how interaction techniques for dealing with data and techniques that integrate data into our everyday experiences can sort of play a role in allowing us to engage with that data in a much deeper and more embedded way. So I kind of want to talk about just 3 or 4 projects that I've done over the last few years, maybe making a few connections back to work that I did here at BiD or work from BiD that really inspired me. All of this work is really sort of situated at the intersection between visualization, CSCW, and interaction design, with lots of little offshoots that sort of sit at that intersection, playing with crowdsourcing tools, citizen science tools, and more recently a lot of work on personal informatics. So first off, I think one of the projects I've focused on pretty heavily over the last few years, especially while I was at the lab in France, has been focusing on sort of word scale visualizations or spark lines. I'm trying to understand how small visualizations and data-driven representations embedded in content and alongside text can actually enrich that experience of consuming media. This really builds a lot on some of the very first work that I did at BiD with Jeff and Manish, which was focused on augmenting user interface widgets to expose social cues or to expose some of the data that was behind those widgets in the Bureau system. And so I've been really interested in looking at how these small embedded visualizations can actually really dramatically change your reading experience, either by providing sort of context, if you're including maps in a news story that includes a lot of references to geography, maybe giving social signals if you're looking at editing on pages in Wikipedia, or even exposing low-lying data about things like OCR on a text document. And there's a lot of really rich questions I think around how you actually do this kind of integration. You can think of just at the really practical level, like what's the right place to integrate graphics into text, and how does that affect your ability to read the text or consume the text? But I think it also opens up a space for a lot of really interesting new interactions where you might actually start to use these kinds of embedded visualizations, get a better sense of the makeup of a document, and even potentially navigate it. At the same time, I've also been really interested in interaction with visualization in larger spaces. So I spent a bunch of time in France actually looking at really sort of low-level perceptual displays of information on large walls, right? So there's this really common problem with large displays, which is that if you're far enough away to sort of see the whole thing, then detail that's at the scale where you'd see it from right up next to the display is no longer visible, and vice versa. So you have this display that ends up being really tailored either for sort of close viewing or far viewing, and it's really difficult to do both without actually changing the content that's being shown. So we had a really interesting project that I liked a couple of years ago, looking at, well, what if we just treat this as a hybrid image, right? So take one of the images that's intended for far viewing and just low pass filter it to remove the high frequency information. Take the one that's intended for close viewing and high pass filter it to remove all of the sort of low frequency detail, and then combine them, and what you get is an image that from up close, you really see one of these two images. From far away, you tend to see the other. And so we actually played around with doing this for really large wall displays where you can actually create information displays that show you high-level aggregates from a distance. As you walk closer, that information basically recedes, and what you're left with is really fine-grained detail. And it's really this kind of sort of low-level use of the limitations of our perceptual system to try to be able to create environments and experiences that are much more data-enriched. I've also been really interested in the last couple of years in thinking a lot more about personal informatics and the visualization of personal data. Something that I think a lot of other folks who come out of here are really interested in, especially TAP, and also lots of other folks in the lab. So really interested in particular in thinking about how you can start to surface some of this information from corpuses of data that we're already collecting about ourselves or already generating. One of these that I think is particularly interesting and that I've been focusing on a lot in the last couple of years is digital notes. In part because there's a really large percentage of people who take almost all of their notes digitally. or take their notes on paper and end up capturing them in some sort of digital form. And I think this is one of the most sort of rich and nuanced kinds of personal data collections that we don't really think that much about as a data source. But there's a whole bunch of interesting things you can do with them that you might not be able to do otherwise. You can reorganize them, you can search them, you can go through the edit histories, you can revisit them, and you can actually analyze them more richly. So I've really been interested in trying to explore this space using a mix of different approaches, right? So doing design probes, doing some qualitative and quantitative field work, and doing a lot of exploratory prototyping. It's really inspired by the kind of diversity of research practices that I think I saw here as a graduate student. So for example, we've built websites that actually plug into people's Evernote accounts and start to provide sort of time-based and topic-based overviews of their note collections. We also allow people to actually submit their own anonymized corpuses of notes and metadata and analyze those to start to understand what kinds of recurring patterns there are in people's notes in terms of editing behavior and revisitation behavior. It turns out there's a lot of different ways that people use digital note-taking tools. We've also done a lot of work trying to do sort of initial prototypes and design probes that explore different ways you might experience a collection of personal data like your own notes. So, for example, providing high-level sort of dashboards that give you a new view into just the timing and the locations and the sizes of your notes that might expose notes that are otherwise just lost in the collection. We've also been looking at surfacing relationships between different ideas inside a corpus of notes, providing sort of like temporal and topical views that expose content that you might otherwise not understand as linked or just might not be able to see at the same time. And we've also been really interested in trying to understand how visual tools might support sharing notes, maybe without actually sharing the content. So could you extract sort of low-level pieces of information about two collaborators' notes and provide this sort of time-based view that maybe shows some high overlap terms that both of you were talking about that seeds conversations, but without actually exposing the raw notes at all. Again, I think it's a really interesting space, and we've been exploring it using a set of techniques that is pretty broad. I think it reflects a lot of the sort of increasing diversity in HCI research, which I really enjoy. At the same time, I've also been working on some projects that are much more low-level interaction techniques. And one of these, which I actually presented here at BiD on a talk last spring, and also which I presented at CHI this year, is actually born out of one of my sort of first projects as a grad student here at BiD. This was a project in Manisha's Viz course, and the subject of a whole bunch of discussion between the two of us over my first year or two as a grad student. So I guess it's proof that sometimes these ideas really take a long time to gel into a real thing. We're really looking at, if you have 2D maps with 3D information, are there meaningful ways of actually exposing that in a way that doesn't complicate the interaction? So if I have a sort of a 2D topographical map, like you might have on a tablet or on a desktop machine, normally, even if I have 3D geometry for this, if I want to interact with it in a simple way, I'm still just sliding and moving this map back and forth, and all of that 3D information is encoded in shading. We were interested in saying, well, what if we actually just provided some kinetic depth cues but maintained all of the standard 2D interactions? And could that additional visual information actually give you a better sense of what the elevations in the map look like? We explored a bunch of different versions of this, including versions for touch devices, where essentially everything that you would normally do with a 2D Slippy map is preserved, but you get much more rich depth cues. And then also exploring versions where something low level like the orientation of the tablet that you might even be doing subtly and not intentionally gives you additional depth information. And then finally, I want to come back to something that I've been really starting to revisit, I think, as a researcher, and that's coming back to some of these sort of more aesthetic and communication-oriented tools that I tended to use as a designer before coming to grad school, as a way of kind of imagining potential futures and engaging in more creative and critical design. This is an example of something that I did for a workshop on interaction and visualization beyond the desktop at Viz last year. And this was really sort of trying to imagine what happens if you suddenly looked forward 20 or 30 years and thought about doing visualization using swarms of tiny drones that were sort of embedded in the physical world and could actually manipulate it. And what are some of the implications of that, both in terms of the kinds of displays that you could build, and also in some of the challenges that that technology might produce. And I'm actually really interested in sort of doing more of this kind of work that is kind of forward-reaching and requires a lot more imagination, but then we can use to ground for more concrete short-term designs. This, in fact, has already sort of led to a bunch of thinking in the paper that's going to be in submission soon, thinking about the broader design space that incorporates sort of potential future designs like these. And this is something that really, I think, came out of the work that some folks at BiD, particularly folks like Greg Niemeyer, really encouraged in coursework and in design, in this sort of fusion of artistic practice and critical design. So this is actually one of the examples that I dug up from when I took Greg's urban detection class that he offered in conjunction with the prof in the humanities. We were looking at designing potential advertising materials here. I was designing potential advertising materials for an insurance firm that might also be sort of a covert surveillance apparatus. Something that even sort of 5 years ago seemed a little bit out there, and in practice now actually seems very realistic, and there are insurance firms that are doing some things that are pretty similar to this. So I really see a lot more value, I'm seeing a lot more value in this sort of much more sort of outward thinking exercise of futuring and the role that can play in our research. I think a lot of that is born out of my experiences here. And then finally, I think others have talked about this, and I know a few more in the afternoon. Well, I think Laura's going to talk about this a lot, but I really want to echo the sentiment that I think as those of us who have cycled through BiD and moved on to other places have done that, we have internalized a lot of the collaborative, interdisciplinary nature of this community. And I really appreciate the mixing of ideas and the encouragement of sort of community engagement and the effort to build a community that happened here kind of organically. And it's something that I've been really interested in trying to propagate going forward. Something we've actually been working really hard to try to do both in labs in Paris and in the lab in Calgary, because I think that there's sort of an awful lot that I've taken away from the experience of being here. And I'm really enthusiastic about perpetuating that and sort of evolving it. And it's exciting to see other alumni doing the same thing. So yeah, thanks a lot.
Thanks. Any questions?
Yeah.
Amazing portfolio. I just had a question about a comment you made about how many people are doing all their note-taking online. Partly because, again, sorry to be such the old-timer, but at Park in the 80s, we talked a lot about digital note-taking and how, would anyone ever do it because we didn't have the right devices at the time, and it was really hard to get data. And then I did supervise some DCs, say at Stanford, where there was people had to scan in paper notebooks, and there was a lot of work on trying to do what you're doing, but there wasn't very much data of that sort. So I guess my question is really, what percentage of people really are doing all their note-taking online? You said 70%.
So I actually don't know broadly. So there clearly are a lot of people who are doing it, and there's some people who are doing it pretty much exclusively. So as part of the project that I was working on, we went out and actually just interviewed and surveyed lots of people who are really, really serious power users of things like Evernote. And there's clearly a big set of people there who have really bought into the system and are just using it for everything. I don't know that it's actually a big slice of the total population. I think most of us still have some interesting hodgepodge mix of note-taking that takes place in a lot of different places. But I think there's this increasing trend towards where you actually could take all of your notes digitally if you want to. And there are at least hundreds of thousands or millions of people who are doing that. We have Evernote's sort of self-published data is to be believed. There's
You said exclusively.
So I don't know about that's a little bit tricky. Yeah, so there definitely are some people who are doing it exclusively, and in fact, a number of people who do, or at least claim to. Who knows where the boundary of that is, right? There's lots of different kinds of things. But yeah.
Awesome. We better move on. Thanks, Chris. So Anka is up. What? By the way, is it a flock of drones or I'll check. Is it a flock of drones or a herd of drones?
I would have said swarm.
A swarm of drones. That sounds good. That sounds more threatening. So Anka is our newest faculty member in computer science, and got a thesis at CMU in the Mecca of robotics, and she works in human-robot interaction and is finding ways to straddle human-computer interaction and also robotics and AI.
Thank you, John. Yeah, so hi everyone, thanks for having me. I'm a roboticist, but I'm secretly an HCI groupie, or not so secretly anymore. So I do work in human-robot interaction. For those of you who haven't heard so much about this, our main conference is kind of like a mini version of Kai. It runs in the same way as Kai, but it's much, much smaller. So that's sort of my home base. It wasn't always like that. I actually made the transition from robotics to HRI, and when I began my PhD, I was working actually primarily in manipulation. So today I wanted to share with you, I thought of, the past 10 years, and I realized I haven't been doing research for 10 years. I've been doing research for only 6 years. But an underlying theme of my research so far has been around this notion of intent. So I wanted to share with you a bit of a journey through intent and robotics. And let's start with this video. So here's a video where this robot, his name is Herb, will use his right arm to reach for this bottle. Okay, so try to spend a moment imagining how you expect that motion to look like. Try to visualize that. And now here is Herb actually doing this. And it's probably not quite exactly what you would have directly imagined. It's not terrible, but it's not exactly what you would have thought. And the reason this motion looks like that is because Herb was just told, here's your starting configuration, here's your goal configuration, find a path from the start to the goal that avoids collision. So we're trying to solve this. It's called the piano movers problem. And actually, John's master thesis is some seminal work. He quite literally wrote the book on showing that this problem it lies in a complexity class that's not easy to deal with. So even doing that is difficult, but that's what roboticists have been focusing on in the realm of motion planning for a few decades now. And the trouble with this when it comes to interaction, when it comes to these robots actually helping people, coming in support of people, sort of looks like this. This is my favorite video from any of the user studies that I've ever run. It's right here. What's going to happen here is Herb knows what cup to grab, so Herb will reach for one of these cups and it will move its right arm using this kind of a state-of-the-art motion plan. She needs to gather the right ingredients based on that cup. So think of this as a coordination task where your part of the task depends on what your collaborator is doing. So let's see what happens. The robot starts moving, and then first she's surprised, and then watch her right hand. She hesitates once, and again, and again, and again, and finally, when the robot, when its hand is very much on top of the correct cup, that she actually knows what she's supposed to be doing, right? And then she has to kind of rush to finish the task. And here it is in slower motion. And I always love showing this video in slow motion because you can see this internal drama, this internal tension that she's going through. So this is a case where if the robot were on its own doing this task, everything would be fine. But now if you want robots and humans to coexist, to share workspaces, to collaborate, you start running into trouble. And you'd think, well, what if we just made the option not go from start to goal and avoid collisions in any way? What if we actually impose some notion of efficiency that would address this? And here's the robot moving efficiently. Imagine you're cleaning up the dining room table with the robot, and you're down to these last 2 bottles. And now the robot will reach for one of these, and you want to grab the other one, right? So think of something like that. Which bottle is the robot reaching for? What do you think?
Front.
Probably the one closer to the camera.
Yeah, so you're actually right. When we ran a study on this, at this point, it was actually pretty close to 50-50. So yeah, so some people think the one on our right, some people think the one on our left. And what happens here is that the robot is just reaching straight for that bottle. It's very efficient. It's using the trajectory optimizer to generate this motion, but it fails at coordinating with you. And so a lot of the work that I've been involved with so far has sort of looked at this problem. So you have a robot, You have a human, the robot starts moving towards its goal. The human tries to figure out what on earth is the robot doing. How can the robot actually produce its motion in a way that clearly conveys to the person what it wants to do. And as we saw in the video before, it's not necessarily about just being efficient. The robot actually has to start reasoning about what the person will think. And we've also looked at the complementary problem to that, where you swap the roles, and now the human is the one doing something, and the robot is trying to figure out what the person is doing. And we looked at algorithms for doing that as well. So both of these problems, what they have in common is that there is this intent inference happening, this goal inference happening, be it on the side of the human or on the side of the robot. And we've modeled this by a Bayesian goal inference. So what's happening is one of the agents has observed this ongoing trajectory from a start point to wherever the other agent is currently. And what the first agent needs to do, be the robot or the human, is infer the goal given the probability of that goal given the snippet of the ongoing trajectory. What we can do here is we can simply apply Bayes' rule, and we don't know what's going to happen afterwards. The agent hasn't seen what's going to happen afterwards, but we can integrate over what might happen, and we can now compute these probabilities by making an efficiency assumption, by basically assuming that when you move, you're going to be approximately efficient in the way you do that. You're not going to go to this goal by doing this. That's a very low probability trajectory. A straight trajectory, an efficient trajectory, a high probability trajectory. So now if you have this, what you can do is you can actually compute the goal that's most probable, and you can do goal inference. And then you can actually compute a policy, we'll call this YG star, that achieves that goal. You can also flip this around and say, assume that the person is running Bayesian inference in their head. We're not saying that that's what happens. We're just saying that that's one way to model, one way to approximate what's happening. And now the robot can actually choose a trajectory that increases the probability of the robot's actual goal given the ongoing trajectory that the person is looking at. So here's what happens in practice. This is the robot now starting with a straight trajectory to the goal on the right and running this optimization that we were just talking about, trying to maximize the probability that the person will infer the robot's goal. And what you see here, this was actually quite exciting to me because the robot is starting to exaggerate the motion to the right in order to make the goal on the right more clear to the user. Does that make sense? So instead of just reaching for this, the robot is sort of going like that. And this is the outcome of doing trajectory optimization on that class function. And what's really cool is that, we ran this, we didn't know what was going to happen, we're just saying maximize the probability of the correct goal. And the robot figured out the strategy of exaggerating, and exaggeration is one of the 12 basic principles of animation. So it's not baffling or mind-boggling that you could use exaggeration for this kind of application. You could use exaggeration to make motion more clear, more intent expressive. But what's really nice is that we didn't have to encode exaggeration in any way. We didn't have to tell the robot, here's the situation, and there's this principle of animation, and it's useful in this situation. Here's how you exaggerate motion. Here's how you make motion more intent expressive through exaggeration for this particular scene. Instead, exaggeration naturally emerged out of the mathematics of intent expressive motion. So we really like that. Now, on the flip side, so with this, we knew that robots can express their goals, and we tested this out in user studies. On the flip side, we also talked about intent inference, right? So this is no longer the robot expressing its goal, but now the robot inferring what the person's goal is by observing the person. So this is a video where I'm trying to operate this robot to do a task. And you can see it's really tedious because I'm not the one actually physically doing the task. I have to take what I wanted, so I'm gonna map it onto the robot. And here is the robot actually figuring out that I want to grab that bottle and then helping me executing a policy for that goal. So at some point, the robot becomes confident enough in my goal and starts executing the policy and helping. And we've seen in studies as well that this works fairly well. And the nice thing about it is that it makes these shared autonomy interactions more efficient. So far so good. And then what we said was, well, what if inferring goals is nice, how do we actually coordinate? What do we do based on the inferred goal? And in shared autonomy, we were just executing the policy for that goal and helping the person achieve that goal. But what happens when you don't longer have a shared autonomy kind of paradigm, but you're actually interacting physically in the same space? What should the robot do based on the goal? So let's take a look at a task that looks something like this, where you have a bunch of different goals. Some of them are for a single agent, so the robot could do it or the human could do it. Others require both of them. So I can't, when I went over for Thanksgiving, I couldn't pick up the damn turkey plate myself. I actually needed help, right? So now we can use intent prediction to figure out what the person is doing, what the person's next goal is. And if we follow what we did in shared autonomy, the robot will just execute, we'll call this G star, and the robot will execute the optimal policy for G star, but that's not quite what we want in this case. That worked really well in shared autonomy because we were able to actually help the person achieve their goal. But if we try to do this here, this is an example of the flip side, where the person predicts what the robot wants and just goes and does it, and that's not what we want to do to people. So we quickly realized that in shared workspace collaborations, intent inference is not enough. We actually have to use that somehow and replan. But then we realized the problem is a bit more complicated than that, because what the person is currently doing depends on, so we want to replan, but what the person is currently doing depends on what the person or affects what the person will be doing next, and what the person will be doing next affects what the robot should be doing next, and what the robot should be doing next affects what the robot is currently doing, and so on. So we can realize that it's not just about replanning, it's about actually looking at the whole collaborative task allocation and looking at what the current intentions are telling us about the collaborative task allocations. And this is the story of 3 students here at Berkeley, Cheng, Jaime, and Jess. Cheng is in mechanical engineering, typical sort of interdisciplinary BiD story. Jaime is in ECS and Jess is in psychology. And what they looked at was, okay, now that we can do Bayesian goal inference, let's do task reallocation. Let's actually plan for the whole task in a way that says, okay, I want to find the optimal task allocation subject to this constraint that right now the person wants to be doing this next goal. So that's what we did. Now, how much time do I have, John?
Maybe about 5 minutes.
Okay. So one pickle here, or one big assumption that's happening, is that the robot is now planning for the person and for the robot, right? In order to figure out what the robot's part is based on the person's current intent, the robot has to also figure out what the next steps for the person will be. And in doing that, the robot is making a pretty big assumption, which is that the person is going to be optimal. They're not optimal now. They have this weird intent, so the robot needs to replan. It's clearly not matching what the robot thought was going to be optimal. So they're doing this weird thing now, but as soon as they reach there and they have that goal, from then on, the person's going to be optimal, right? That's what this assumes. And that's quite a big assumption. So what we wanted to do is we wanted to test this out and see whether, despite this big assumption, despite this way of modeling human behavior that's clearly not entirely accurate, whether doing this task reallocation would actually still be beneficial in these collaborative tasks. So we ran a study where largely we looked at 3 conditions. So normally, okay, so we have these types of tasks where some of the goals are for a single agent, other goals need both agents, and the robot computes its plan, and let's say the first step is for the robot to go to that goal, single goal. Now, in one of our conditions, the robot would start executing its plan. Then the person would observe what the person is doing, predict that their goal, in this case, for instance, is right here, and use that information to replan sort of preemptively, and in this case, it would go to that goal and get there even maybe before the person got there. So we call this the predictive condition, and that's what I described in the previous slide when we talked about task reallocation. A second condition was where the robot was executing its plan, but it would actually wait for the person to achieve a goal. It wouldn't be doing goal inference. It would just wait until the person actually reaches the goal, and then it would be. So we call this the reactive condition, because the robot was reacting to the person, but not really being preemptive, not really anticipating what the person is doing, just reacting to what it's observed so far. And then finally, we had the fixed condition when the robot was stubbornly doing whatever it thought was best and expecting the person to adapt. So we hypothesized that despite our ridiculous optimality assumption, we'll still see an ordering of the conditions like that in terms of task performance. And then we also looked at a different variable, which was how are these inferences being made? Are we actually doing realistic Bayesian inferences, which sort of correspond to the state of the art and what robots could potentially do? Or are we just using an oracle to tell us exactly what the person is doing? So assume a world where we had perfect knowledge and we could just infer people's intentions by, scanning their brains or something like that. And we thought that, well, of course, if you have an oracle, things are going to be better. So we used 15 different stimuli, so there were all these different tasks that participants went through. And here's a little bit about what we found. So the most important part, and it's not too unexpected, is that when you look at the completion time for the human-robot team for these tasks, you definitely see this kind of ordering that we expected. In other words, being predictive is better than being reactive, which is better than having a fixed policy and being stubborn about it. So that's what we saw, and we saw this in the oracle condition as well as in the Bayesian condition. And despite this optimality assumption, which was encouraging, we also saw that, of course, as expected, having an oracle is better, right? But at the same time, even if you don't have an oracle, you're still better than not doing this anticipation of just being reactive. A little bit more, it turns out that people did less and robots took charge of more of the task under these conditions. So the robot alleviated the human's workload. And I think most importantly, people actually noticed. And although the task efficiency findings weren't that surprising, what was personally surprising to me is that people actually noticed and were realizing again and again throughout these tasks that the robot is actually adapting to them and actually appreciated that. And you can see these differences becoming stronger and stronger over time. So people notice and appreciate adaptation. This also affected all sorts of fluency and collaboration metrics. I think, wrapping up, what's exciting to me about this work is that typically we do intent inference from motion or we do task allocation, but here we actually looked at how these have to influence each other. And I think this is kind of the way to go moving forward. And to pop up even one level, I think these notions of intent are becoming more and more important. And so far we've looked at goals as our definition of intent, but transparency of internal state is, I think, more and more important on the human side and on the robot side in all sorts of applications. And I'd be excited to look beyond goals to actual behaviors and properties and even emotions and so on. So that's where we're sort of looking at forward, and I think autonomous driving could be a really nice application for that. Thank you.
Awesome. Any questions? Yeah.
So to what extent do the mechanical limitations between operating and sort of the entity that's doing the action help dictate the intended action? So for example, if I'm reaching for something like this, I'm probably you sort of have a sense of how I'm going to grab it versus if I'm approaching it this way. If I'm reaching something high up or in some strange orientation, you know, based on limitations of my shoulder and my elbow, what I can and can't do. So particularly for the robot, since its anatomy is very different from human anatomy, does that impact how people perceive its abilities and therefore what it will potentially do?
Absolutely. So in two ways. So one, when it comes to humans inferring robot intent, so far we've worked with somewhat anthropomorphic robots. You're right that the kinematics were fairly different from human kinematics, but it was still a 3-1-3 configuration, and you can sort of think of something as the shoulder, the elbow, the wrist. And in that case, we were lucky. I think as we go to more and more non-anthropomorphic arms, either arms that look really, really weird and almost snake-like, then people have not as defined mental models of how the motion will look like given a particular goal. So if you remember the way we do Bayesian inference, it relies on this efficiency assumption of people expect that the robot will move efficiently towards that goal. Well, that notion of efficiency is completely different now. You have a different kind of robot. So that's one way that it affects things. So you need to look at how you can maybe train people and habituate them to a particular cost function, or you can learn from demonstration and have them show you what they expect and so on. So we're looking into these kind of problems. But also, on the flip side, when you're actually teleoperating the robot, that also is very difficult when the robot has different pneumatics from you. Because again, you don't know what its turn limits are, you don't know what its capabilities are, and doing this, we call this a skill mismatch problem, or a retargeting problem in a more general sense. But when we demonstrate behavior for robots, we think of how we do it. That's the best way for the robot to do it, and that's because we don't really understand what the robot can do. So we're starting now to look a little bit at how robots can express their capabilities. You know, stay tuned. It's just one of the projects that's in the pipeline.
Okay, thanks again. All right, so we have some box lunches and drinks set up at the back of the room. That's your lunch, or you're welcome. We're set up here, but you're welcome to take the box. We made them mobile in case you wanted to visit BiD or do something else with your time. And it's even not terrible outside. I think it's dry right now, not too cold. So help yourselves, and we're going to resume at 1 o'clock with Jetpack.
Do you want to have a data science session?
Yeah, I got to. I'm going to have to go there, and it's in Jacobs. So the new building, right? Yeah, third floor.
Okay.
Yeah. So, yeah. Oh, absolutely. Welcome to come. Yeah, and we'll have more projects. So that one we didn't so much put on the schedule because it's not really HCI, but we have 3.
It seems that this is your major research focus nowadays.
Yeah, not 80%. I would really like to do a bit more application. We do have some work. We submitted something to Kai that's kind of like data exploration. We described it as synthetic. It's not like that at all. But the idea is to sort of use deep learning techniques to kind of analyze people's really feelings and more qualitative things from some big repositories of social media. So we are trying to do some applications of the data, but yeah, mostly I'm doing the data stuff now.
I just have my second kid last summer, and he's 1.5 years old now. Justina, you know her.
Yeah.
Much bigger now, 11 now.
Really?
Yeah. He's 1.5 years old. He can run really quickly now.
I remember you're seeing your baby when she was a baby, your first kid when she was a baby.
Yeah. She was born in 2004.
Unbelievable.
Yeah, maybe I can catch up with you later when maybe during lunchtime or in the afternoon.
Yeah, I'll see if I can come in and out. So I don't want to be gone the whole of that period, but I need to check in a bit of grade.
Yeah. I looked at syllabus of the data science guys. Seems to be very interesting. I like to take a look at.
Sure, absolutely.
Take a look at, for example, posters.
Yeah, no, and absolutely. We really like feedback because it's not easy to teach that class because there isn't, right now there's not really similar classes. Data science means different things to everybody. So I'd love to hear what you think. Also. All right, thanks, Gina.
If you don't mind, just
Hi.
1 minute of
Yeah.
Hi, Amelia. I wanted to apologize.
And I also Someone
Saturday morning happens to be well, I'm on my car and you go followed by some people. This is awesome. No, so and we have our funny from one thing to the next.
And then just like, and then there's like here. Like, never done.
How long? Probably used to be over. Like if you're in this.
So once both will like walk.
Yes, that would be a real problem. That's about the least safe. Yeah.
Into a chair.
We got one so. Yes.
Yeah.
These are really definitely questions that are looking at another goal is exactly around questions of strategy, really working with today with the minority population. We were working with both women and middle school to high school. So we got a research meeting where I did it myself before I was in my last I've been doing it. I think it will be the same next semester. Yeah.
Okay. Yeah.
I'm going to try to keep Friday. Yeah, that means early next semester.
I'm also doing so searching.
You're first year today?
And when I talk to people, they might forget that I know.
I don't think I
work in
They have extra money to throw away for an extra couple years in that area, and I think you're doing whether the federal workers.
that
It's like no opportunity to share that or anything. It's just, yeah. That's actually close to it. That's, yeah, that was actually.
Because like those computers that's like matches on
So good to know that we have it. Yeah, that's if you were to show one person one future papers, I saw
Hi.
Yeah.
In the lab, we have like these two huge piles of things we should dispose of. And I am not sure if we can just like dispose of them or we have to ask you, Joe, or Alice.
Okay, so yes, to send an email to all the faculty and say, we've made these piles, we think it's all disposable. You have 1 week to stop by and take a look and claim. Yeah, I think that's fine.
Okay.
Like, if you want to give them a little bit more time, do it end of next week, like Friday next week. By then, either we make the time to stop by and claim anything, or we can just go.
Thank you. Yeah, I just wanted to make sure not to do something wrong.
Okay, so I should email. Yeah.
I have this live hangout, but yeah, if you email him, I guess I could try to invite him.
Ah, you can add him just to this hangout,
I don't know.
or am I just gonna connect and you're gonna film the screen? Or
Let's just do that. That'll be an easier method. I'm having to keep the broadcast running because otherwise it will make me send out a new link. I know. I guess I should just like
Say something?
Not hearing anything on your end.
Aha. We can hear you.
I guess half duplex is better than no duplex.
How about now? Can you hear us now? Can you hear us now? Are we still half duplex?
No.
Still silent, unfortunately.
Oh, I could. No, that won't help.
I can speak into the void. Yeah, I'm not sure how that will work as well for screen sharing. I have no idea, but let's try. I'll give you my Skype ID here.
Hey, can you hear me now?
I can, and
Magic.
the opposite thereof.
All right, we'll give everyone here just a minute or two to get settled down, and then you should be able to screen share through conversation, share screen.
Yeah, okay, let me get this together.
Yeah, we can see that. That works.
Okay, is the aspect ratio and everything good enough? You can read everything?
Yes.
Wonderful.
All right, everyone. Find a seat. So John had to run to do his final poster presentation for his class, and so I guess it's on Eric and me to corral you all for our afternoon session. And we're going to start out with Jeff here. Jeff, your name's been dropped plenty of times over the morning session. So,
Oh,
in many different kinds of contexts. I'll leave it at that. You can decide whether it's what that means. So Jeff is Skyping in from his home at UW. And Jeff, please take it away.
great. Hi, everyone. Thanks for having me. For those of you I haven't met before, my name is Jeff Hare, and I was there at Berkeley and BiD from 2002 to 2008. And I'd start off by sharing some research we're currently doing in my lab here at UW. You can see like the list of my PhD student and postdoc collaborators. We're kind of the latest in an evolving set of projects concerned with how we construct and express interactive data visualizations. And so an overarching goal of research in my group is to build an ecosystem of visualization tools, not a singular tool, but rather a set of interoperating tools that support exploration of data and also allow custom design so people can more effectively communicate research results. So let me give you some examples of the type of visualizations that might include. Let's say we're interested in, for example, air traffic in the United States. Here's a not very useful visualization that plots the graph of all direct flights circa 2008. So to better probe the structure, maybe we want to use interaction instead. So as I mouse around the map and I get near a particular airport, I can see the direct connections, and in that way, combine visual encoding and interaction as a way to better understand the data or to focus on particular tasks. And so while some of the things here are obvious, the use of a map, in this case, the use of size to show the relative traffic at different airports, interaction is an equally important component. So for example, if I double click here, you can actually see that the interactions are accelerated similar to a bubble cursor by using a Voronoi tessellation to select the nearest point at any time, thereby making interaction and selection that much easier. Here's another example. This is a scatter plot, not unlike what you might see in a talk from Hans Rosling and TED. This is showing global health statistics, plotting fertility against life expectancy. This case currently in the year 1980. I might want to know how these things evolve over time. So for example, mousing over the point that represents a given country, I might also overlay the trajectory of the statistics across time. Moreover, I might want to say, if I'm interested in Peru, I might want to drag it, whether using my mouse or touch, and then as I see its different position, also assess how the rest of the world adjusts accordingly. So having new ways, for example, in this case, to navigate through time. And of course, there's a whole variety of interaction techniques and visualization we might want to support. Link selection or brushing and linking is another common one. In this case, we're looking at 4 different charts concerning flight delays, including when a flight departs, how delayed it is, the distance it traveled, etc. And I should be able to use any of these charts, not just as information carrying displays in their own right, but as input devices. So for example, if I select all the high delays, I see they tend to correspond on the left to flights that leave later in the day. Whereas if I select the entirety of this distribution, I see a more uniform distribution on the far left. So in this way, I want to be able to probe the high dimensional structure of data in addition to be able to seeing it. And we want to be able to support this across a wide variety of visualization types and data types as well. So each of these examples are actually built using Vega, a visualization grammar that we're developing in my lab. If you don't care to listen to what I have to say, that's fine. Just go to this URL and play with the demos and see for yourself how well it may or may not suit your needs. But at a high level, what we're trying to achieve here is what we call a visualization grammar. And so similar in this spirit to how SQL or structured query language provides a high-level representation for database queries, we're trying to similarly explore high-level models for describing visualizations. Now, one reason to do this is to create visualizations ourselves, but it also has other use cases as well, which is it provides a formal model for enumerating and reasoning about visualization designs, which means we can begin to explore algorithms and systems that actually search for visualizations, recommend them, generate them programmatically. And so one of our key results in recent years, I won't go into a lot of detail here, but one thing that we're very excited about is that in addition to standard grammars of graphics, we've come up with ways to express interactions in a declarative format. So borrowing ideas from functional reactive programming and data streaming, we're actually able to express interactions in this high-level way without imperative callbacks. So really a new model for trying to author interaction. And in terms of technical bits, like these visualizations are actually represented in a JavaScript object notation format, which is then parsed and compiled to a reactive data flow architecture, which does everything from event processing, data transformations, and rendering, and it supports efficient incremental updates. So you get nice scalability with the number of points, for example, on your display. This is actually open source software. The Vega 2.0 series of releases started in July 2015, and we have an active user base out there in the world. So kind of underneath the hood, we use kind of standard web technologies. JavaScript is the main language on the client side, SVG and Canvas for rendering. And we heavily leverage utilities from our prior work on D3 or data-driven documents, a very popular visualization library. But the more important point here is that we can actually use these higher level languages as a foundation for new applications. So for example, Lyra is a design tool that my student Arvin created on top of Vega and uses Vega as its way of representing visualizations. So this is actually a graphical interface in which you can hand construct visualizations in a direct manipulation manner. Really sort of our answer to the question, what would an analogous interface for data visualization be compared to something like Adobe Illustrator? In addition, Vega has been adopted as a standard by the Wikimedia Foundation. So you can actually go to Wikipedia, add visualizations to articles using Vega as the declarative specification language. It's also been integrated in a variety of libraries in different data science environments, including IPython Notebook, Jupyter, RStudio, and Julia. So it's kind of a growing ecosystem of tools built on top of this foundation. In addition, we're exploring even higher level languages on top of Vega as a base. Vega is fairly expressive, but also more verbose than you might like for rapid analytics. So Vega Lite is a shorthand language my students created, more akin to what you would see in tools like ggplot or underneath the hood of interactive tools like Tableau. And so indeed, using Vega Lite, we can actually build a number of user applications. So on the left is Polestar, which is a web-based version of Tableau. And actually, we're actually able to do working but rough prototypes of this entire application in less than half a day by using this high-level language. Now on the far right is a new research system we recently published called Data Voyager, which actually searches over thousands of possible visualizations represented in Vega Lite, ranks them according to both perceptual and statistical principles, and use them to populate a browser in which users can interactively explore recommended visualizations for their analysis tasks. So again, hopefully we're getting to see how these different components come together, not just in a single tool, but in an ecosystem of interoperating tools. So for example, you might build a custom design in Lyra that may even be the result of the output of a Vega Lite tool, further fine-tune it at the level of Vega, or even just export it as a static SVG and play with that in Illustrator. The idea is to provide multiple avenues depending on what your task is, ranging from rapid analytics to into custom design. And of course, I left the upper right box empty because there's lots of future work and projects to explore in this space. So just a brief sample of some of those possibilities. One active area we're working on is scaling up visualizations to larger and larger data sets. So far, the work on Vega is focused on the client side, but because we have a full declarative representation, we can actually take a lot of those data transformations and partition them to run on a server backend. So thinking about how do you dynamically partition these visualizations for scalability is an interesting challenge, particularly given the feedback loops that interaction techniques introduce. So sometimes you'd like to do something quickly on the client, other times you'll have to push back to the server due to the data volume. We're also really interested in continuing to explore higher level languages. Our interaction techniques at the Vega level are pretty powerful, but still involve a fair amount of wiring up of different interaction signals. We'd like to know if there's an analogous language at the Vega Lite level that makes it really rapid to put together common interaction techniques. We're of course always looking at new ways to build end-user facing interfaces to let people build visualizations, but also to better debug these languages that we're creating. And ultimately, we hope to support analysts, whether they're domain scientists in academia or analysts in industry, to really build tool stacks that speak to their needs. And so if you have a familiarity with these or other tools and have ideas of what would be most useful, I would love to hear your feedback. So certainly feel free to send me any questions or thoughts offline. With that, I just want to spend a few minutes kind of talking about how BiD has played into all this for me. The Vega project that I just described now is actually ongoing work we're doing here at my current academic home at the University of Washington. And in itself actually stems from years of research we did while I was on the faculty at Stanford, where we built popular tools like ProtoViz and D3. But all of these is part of a much longer lineage of projects that go back to my time at Berkeley, where initially I built visualization frameworks, including Prefuse, which was in Java, and Flare, which is in Flash. And really, it all goes back to BiD. I remember when I started on Prefuse, it was a class project that Al Neuberger and I were playing with, and then I just continued to develop it. Many people told me it wasn't research and that I shouldn't waste my time on it, but fortunately I got the support and mentorship, so to both persevere as well as to really think about what I was doing and how that translates into actual knowledge contributions. And that came from the great mentorship and peers that I had there in BiD at Berkeley. So some of those folks, so here's me, actually a much, much younger version of me, hanging out here in Hearst Mining in front of a Prefuse visualization on my screen. My intrepid colleague, Ty Rattenberry, is sitting there in the back, obviously hard work. I'm actually, one of the things that was great about BiD is lifelong friends that I made. So actually, Ty is now actually works with us at Trifacta, which is a startup company Joe Hallerstein and I founded with my Stanford student, Sean Candle. So many of these folks that I sat next to, I'm in touch with to this day. That includes my initial CubeMate, Al Neuberger on the left here, and the person that used to occupy Ty's seat in the previous picture, Scott Lederer on the right. Certainly lifelong friends I've made. Unfortunately, missing from this picture is Chris Beckman as well, who was in my cohort. And over the years, I got to work with lots of amazing people there. So after Alan moved out, I gained a new CubeMate, the intrepid Wes Willett, who I see sitting there in the audience, who to this day impresses me for many reasons, not least of which is his ability to grow intimidating facial hair. But here you can see, that we get very passionate as well. You can see, his kind of zombie eyes as he contemplates what he's about to do, which is, yes, eat a cheeseburger that has grilled cheese sandwiches as the buns. And then on the right is Scott Clemmer, who I've been very fortunate to work with, both at BiD and then later at Stanford. A lot of my thinking and the way I conduct research was shaped by his feedback, something I'm extremely thankful for. And you can see here that he is similarly entranced with very cool drinks. And so the last point I just want to raise is that while I had these amazing formative experiences at BiD and made lifelong friends, I also just want to point out the really wonderful place BiD occupies within the larger community. And it's just one simple set of examples of that. I started at Berkeley. Here's a picture of me showing that I now have more hair on my face, less on my head, and my eyes aren't quite as good as they used to be. Oh well. I graduated and went to Stanford, had a wonderful time there, and then eventually moved on to UW. As I alluded to earlier, similarly, Scott Clemmer came out. His experiences and my experiences at BiD both enabled us to get these really top-notch academic jobs. Scott, unfortunately, we parted ways as he headed south. And others made very wise decisions to come to BiD. So I was very thankful that when I moved to Stanford, we had a tit-for-tat trade as Bjorn came and made the right decision. My advisor, who I'm indebted to in many ways, also made the wise decision of coming to Berkeley before getting unfortunately turned around. And of course, there's other trajectories as well. So a very prominent figure in the early days of BiD was my undergraduate and master's mentor, James Landay, who's made all sorts of confusion up in weird places, and then landing sort of in the strangest of spots. The point being that we're part of a much larger, which BiD is at the center and really a vital part of larger conversations in human-computer interaction and design. And so I'm certainly very thankful for my time there. I'm also very thankful for things that are a bit less transient, which is John's guidance, leadership, and really his fostership of the lab space and the group as a whole. So unfortunately, he's not in the room, but I do want to thank him as well for all of he's done to sort of maintain the continuity of the group over many topsy-turvy developments. So with that, I hope that for all of you who are currently in the lab, that you're having as important and as formative an experience as I have. And thank you for your time, and also thanks to everyone involved with BiD for the great memories, but also the preparation that's really led to a really fun and successful career. So thanks.
Any questions for Jeff? Well, so yeah, sets up.
No.
You're back.
Yay.
Yes, okay, good.
A question. I had one, and that was to what extent the kind of primitives you find in Vega for interaction are specific to interacting with visualizations or with pixels, or to what extent you think they can generalize to other domains of interaction. Like we have a bunch of people from SynMat in the room, doing computer music and live performance and.
Yeah, no, I actually think music and live performance would be a great area where I think those ideas, which we adapted to visualization, but many of those stem from prior work, particularly in functional reactive programming. I think it's really positive. I mean, really, what functional reactive programming boils down to is you have primitives for streams. In event-based FRP, it's really discrete streams of events, and then a notion of what's alternatively called behaviors or signals, which are really expressions over those streams that can update dynamically, and then any changes to those values propagate basically through a graph of dependencies. This works great for visualization, at the level of doing interaction techniques, for which I think many user interfaces might also benefit. But what's great is it also provides abstractions in the form of these signal variables or higher level predicate functions and in terms of them that you can use to select data, to parameterize query operators, or even directly to parameterize visual encoding rules. So the nice part that makes visualization so convenient is that the rest of the application already has these very well-defined declarative semantics, and there's just this really elegant coupling of what an FRP perspective provides with what you would do perhaps in a more streaming database context. I'm less familiar with music, but given sort of its focus on time, in particular, I would imagine a lot of the semantics are incredibly valuable there as well. I think to make it to apply to interfaces more generally, what you need to consider is then what is the sort of state model of the remainder of your application to understanding how these different components most elegantly come together. And so I think I think it's a really promising paradigm. We've been using it to great effect in visualization, and I think a variety of other domains could similarly benefit, but that exploration needs to be done.
Okay, thanks, Jeff. All right, and I think we'll move on to next speaker.
Everyone, sorry I couldn't be there in person. Hello to everyone.
Hi, Jeff. Bye, Jeff.
Anybody has a clicker here? No. Okay, that's fine.
Hi, everybody. My name is Soyoung, and thanks for having me this opportunity to speak a bit. And so I currently work as a postdoc at Hospital of Business here, and my topic is less technical, which is food. So actually, when I first came to Berkeley, I was studying airline industry, like studying service innovation of Ryanair and Virgin Atlantic. And I just fell in love with food scenes in Berkeley at first, second year. So I changed my topic to food, and I just got so interested in the aspects of chef as a designer and an innovator. And when I started this project, and I went to a lot of chefs asking, what's your innovation process, design process, the business model, and they said, no, we don't do that. So I actually found that I don't speak the right language, so I had to change my entire concept. And actually, the first thing was I actually had to become their friends and become a part of the community of chefs. So I actually started the volunteering at the Edible Schoolyard and going to a farmer's market to volunteer. So I just slowly became part of their community. So I guess everybody know about this restaurant in Berkeley, started by Alice Waters, who is a Berkeley alum. And this happened to be actually an interesting moment. I actually started a passion for studying food. So my co-advisor, Henry Chatsborough at Hospital of Business, who coined the concept of open innovation. So he actually treated a few students lunch at Japanese. And I just found something very special about this restaurant. So I literally went back to the restaurant next day and then asking about, oh, what do you do? And I just asking so nice questions. And I had a really nice conversation with the general manager and who used to be a chef. And then she actually told me so much about history. So, so it almost became a history project that I actually had to study about how this restaurant started it and what's so meaningful about this, the American culinary cuisine, you know, and so on. And I actually found out that it started by a free speech movement. So Alice Waters, she was part of the free speech movement, and she used to cook for fellow protesters, and they became actually Alice's restaurant. And that's how she started her career as a chef. And so this is the lady, and so I got to know her pretty well, and I spent a lot of time in her restaurant, kitchen, and her alumni restaurants, and so on. So interesting about this restaurant movement is they actually it almost served as a grad school of chef. So I checked them about 500 chefs and their career path and how they actually generate new dishes, how they create this culinary movement all over the world. So that's how I actually started getting to a lot of data. Yeah, so I found out that they have a great community of people, for example, alumni chefs, and corporate partners, and the local purveyors, and artists, and the wine sellers, and food journalists like Michael Pollan, and educators, and so on. So I found that the creativity process and also design process of new meal, it's actually coming from the community. So I studied as a open innovation, you know, framework. So I studied as this is a community innovation. So that's my study. So, and then after I finished my PhD, I started working as a postdoc at the Haas School of Business, and my center is called the Institute of Business Innovation, and we do a lot of interesting kind of business innovation activities. And one thing I'm running is food hackathon. So I've been running food hackathon with food companies. For example, this is something I did last April with Chill Chocolate. Do you know about that company? So TCHO is actually technology meets chocolate. So they do a lot of data innovation to understand the customer needs and the buying behavior and so on. So I did you know, the hackathon with them, and Professor Alice Agostino and I are working on comparing California cuisine to Nordic cuisine. So this is my visit to Restaurant Noma. You know about the restaurant? They have been ranked as a #1 restaurant in the world for several years. So they are in Copenhagen, and they do a lot of foraging and hunting to bring these native you know, ingredients. So we're comparing to their cuisine itself and leadership and ecology, innovation culture, and so on. So it has been a pretty fun project working with the top chefs about their business model, innovation processes, and so on. And then I work with RCA, Royal College of the Arts, on open food projects. So they have a cake lab, so they call it as a cake study. And they have a laboratory in London to study how this baking practices can come from our community. So we work with the bakers and you know, the culinary experts and just general customers. How can they co-innovate this baking practices? And University of Bologna, Italy, I work with them through a food innovation program. So they have food innovation incubator, and it's almost like a tech shop version of food. So they actually have all kind of tools and hackings and all this kind of interesting activities in their facility. And they actually partnered with World Expo earlier this year. And then they actually work on this 3D printed food now. So I work with them. And the last thing I work with is Lego. So the Lego Foundation in Copenhagen, they are actually working on future project, which is edible Lego. So we to see how this edible Lego can be useful for food education for children. So that's something I'm working on. And next year at Jacobs Institute of Design, we're going to host the Stanford Food Innovation Symposium with famous chefs like Alice Waters and Klaus Meyer from Restaurant Noma. And then we also gonna bring Chef Watson from IBM to see if we can run the Master Chef show between human being and, you know, the machine chef. So that's what I do. And I guess I'll take some questions and yeah.
Is the blocks of the edible Lego, are they actually edible or are they just made out of plastic?
No, it's actually edible. So
it's cornstarch based or what is the material?
It's a plant based, and they're kind of trying with the crackers right now, but you know, they're actually trying with all kind of different materials. I just visited Hampton Creek in San Francisco last month, and they make everything based on plant. So that was pretty interesting, and they said it's pretty safe to make mayo and scrambles and based on plants. So
do different colors taste differently?
Yeah, it's a color coding.
I want some for Christmas.
Any questions? Please.
Oh, this is really cool work. It's like, I mean, somehow you managed to get this really great sort of research lab, which is Shape and Ease. I don't get to work in a place like that. That's pretty amazing. So, can you say something more about this symposium that's coming?
Yeah.
Is it gonna? How do we get involved?
So, Alex, you just came in the right moment. We are going to talk about this food symposium next year. So we got a small grant from Peter Seder Foundation. Peter Seder used to be a Norwegian banker, and he endowed a lot of funds to his wife. And actually, Peter said we have a Peter Sedergate, right? So Sedergate and also Campanile was in that, you know, from the Peter Seder Foundation. And so we got a small grant to start this conference. And we have a great connection to Stanford D School and Center for Design Research. So we decided to co-host this event to make more broader. And we are going to also bring people from University of Copenhagen and Restaurant Noma. And there are some industry people who want to get involved as a sponsor. And actually, we got some sponsorship from BiD, I mean, Jacobs Institute, because they want us to host that event. And I think that's how we can actually work with BiD.
But we also have a planning committee if anybody wants to join us. We have great fun. We try to sample the goods. And we'll have a design thinking workshop.
Yeah. Good. So I just want to conclude my talk by thanking people here. I think it was a great opportunity to work on this new topic, which is food. A lot of faculties were very concerned if I can graduate with this topic because it's really less technical and, you know, it's very unconventional. Initially, some faculty were not happy about this topic, but somehow they actually gave me freedom to manage. So I'm very thankful, and I had a lot of fun. And
I was not one of the ones
that for the record.
Thank you.
That was great. There's a really great photo of Alice Waters that she's actually like at these protests, at the free speech movement protests. All right. Okay. All right, so I'm Eric Paulos, on the faculty here, and before that I was at Carnegie Mellon as faculty, and then before that I was at Intel Research here at Berkeley. They had these research lablets. But before that I was a grad student actually at Berkeley, and part of this very early time at BiD. And so I'm not going to show you the research I'm doing now. I was going to reflect back on some of the origins from what I see from BiD and the kind of just appreciation I have for a lot of the people that were way above my pay grade and made things happen and created an amazing ecosystem for, I think, a lot of things to flourish. Because the people without the knowledge of their past history, origin, and culture is like a tree without roots. So we have to go way back. It's going to get slightly scary. This is the first scary photo. This is my initial grad school card. They issued these back then. Oddly enough, when I joined Berkeley, I had the same number. It still said that I had like some paycheck waiting from grad school. So when I came back as faculty. Now let me just switch really fast here. If I can. Okay, sorry. So some of this predates BiD, but it leads into it. So when I first arrived, this bright-eyed, a lot of hair on his head student, I was doing robotics at the time, and there was this object. This is this thing called Robot World that sat in the lab over in Soto. There's also one in Corey. And you could control it. It had a little arm that it actually moved very unusually without moving parts. It was all kind of magnetic, and things sort of floated on an air bearing. And we controlled it to do some early research. This is what I actually looked like back then. And it was very mathematical. We're doing things around probing and actually just like assembling things. And we were trying to figure out some ways that the kind of mathematical duels between probes and grasping and optimizing the way that you would actually create these kinds of structures. But what got interesting was this thing, the web sort of happened in the middle of this. And I suddenly realized you could maybe put a camera and start to allow people to move this thing around. And one of the first projects we did was this thing called Mechanical Gaze back in 1994. There were only 2 other robots online at the time, one in Australia and one at USC with not yet faculty Ken Goldberg, who was there. And we set it up so you could go in and observe and sort of move this around, take pictures of museum artifacts. John was really interested in that. And you'll see that weird picture at the top. There's a gecko lizard. And I don't know to this day why, but John brought a gecko lizard in, and somehow that became part of this entire project, this live gecko lizard. I wasn't sure if this is pre-IRB. We just had this like lizard we had in this thing. And it's just, I don't know what that was, why we had that lizard. But this lizard showed up, and we were very concerned about keeping the lizard alive. Like the rumor was we would not graduate if this lizard died. That was like, we had to keep this lizard alive. But we also were interested in allowing, people often said, this looks really cool, but I don't really think this is real. You just pre-store these pictures. And I got really interested in the kind of, how do you sort of prove that it's real, or does that matter if it's really real? And so collaboratively, again, John and I and Ken Goldberg and some others created this project, Legal Tender, where we invited people to come in. And actually, this is when the new $100 bill was introduced. People were trying to get familiar with it. We said, you can come in, own a little bit of this bill, and actually burn it or puncture it. You can perform experiments. But if you do that, we're actually going to, we know who you are because we've taken some information, and we're going to remind you that it's a federal offense to actually do this. So we're setting up this potential criminal activity online. I should say at the time that I was always doing things at the lab and doing things outside the lab with survival research labs, with some early kind of bringing kind of robotics out in San Francisco. I was riding around on my motorcycle at the time. But when I really think about the people, it was this group. And these are the sort of cohort of students that I work with. That's the now home of Jacobs Hall behind us there. Francesca Barrientos was one of my office mates and an early member in sort of what became BiD. She went on to be a user experience design strategist at Cisco, and she was also at Park and NASA. She's at Cisco now. Yan was also a student of John's. He was then hired as not employee number 3, but the third of John's students to go to Qualcomm, where he's still there as a sort of director. So it's Paul Jacobs, Greg Heinzinger, and then Yan. And then this strange Brazilian folk, this is Dan Resnick, with a ton of personality and energy, although it doesn't look like it at all here. And he was very much a tinkerer. He ended up, his thesis work was on this thing called this universal planar manipulator. So it was this object you could put things on and magically move them any way that you wanted. I found a very old video and wasted like 20 minutes converting it from a weird like format in real audio video. You really want to know how long it took me to convert this video. But you could set things on the surface and move them almost like magic. You could just have them do whatever you want. You could drive them right and left. Now this seems maybe not that interesting to you. Like, okay, there's some kind of a field that's there. There was always wine around the lab. Also, John insisted that all the machine names were wine. So mine was Medoc, and there was, Bordeaux. All the machines had names with wine. What's more magical is things like this, when you move things independently. So he can say, well, this coin should come forward and the other ones will just stay there. Very magical indeed. And I brought it. It's still sitting in BiD. Here it is, right here. Didn't you wonder what that was? That's what that is. You'll notice there's no audio because it was extraordinarily loud when it was running. So also A.D. Elliott, who was a big member of the early days and now actually came to my class just last week and gave a really nice presentation about careers in HCI. She was at Park and IDEO, and now she's gone on to do this really great nonprofit, Simply Secure, which really kind of feels very Berkeley to me about how do you design security and privacy, but with a kind of HCI focus. Allison Woodruff, Paul Aoki were two other colleagues that were doing HCI at the time, but we didn't know what we were doing. We were sort of didn't have a lot of direction except for John. And then they went off to Intel, now they're at Google. This is what my office actually looked like. That's actually like how crazy it was. And earlier, John had played with this other name, the BiD and Robotics Laboratory. I found this old thing, which he could never figure out what the acronym stood for. At one time it was visual and virtual environments, but I don't know, we were sort of always playing with it, so then it became BiD later on when he was thinking more about trying to go away from just the mechanisms of robotics. You all know about these blimps and things. This is some of the earliest pictures of me screwing around in the lab going, what the heck are we gonna do? Even though it's completely not thought out at all, so much so that it's not even composed. The picture is taken at this weird angle. And this was one of the first emails John sent me. He got this Wacom tablet, so he drew that sketch and sent it to me. The gecko is there. Again, I don't know why the gecko is there. That was never part of the project, but it was like a hint, like keep the gecko alive. And there's John, what's going on. Okay. And then most of you know, we made a lot of really, we had a lot of fun with this project and created some really interesting ways to think, not just playfully, but also critically ask questions about how people would interact across a distance. And we brought these things to Ars Electronica and had some kind of artistic versions of interacting with these. We let them float around the building and get stuck on things, and they got caught in rafters and had some really interesting interactions. Now, technically, it was very complex, and now it seems like you could build it like that. So it's funny to think of my whole dissertation as a 99-cent app, but that's kind of what progressed. Luckily, it was really early on, so someone mailed this to me recently. I didn't generate this picture, but it shows the kind of ecosystem developing from that. And it was a really fun project to see it kind of develop from, these are pictures from my dissertation, and then these are pictures from marketing, and they're sort of clearly kind of a related story there. About 17-year gap. Now, when we played around in the lab, you could see the technology is pretty old. Joystick, I had a quick cam, really kind of older things. You would meet sometimes Turing Award winners in the hallway. But it was a really messy process. Okay, so this was like an absolute nightmare to go and debug, and I spent countless hours sort of twiddling with this thing and futzing with it. And there were multiple versions. This is another picture of me, but as John was sort of thinking about the lab, we had this workshop next door, which I kind of took over and built a number of projects. Some may or may not have been related to research. But the one thing you'll notice is this tool chest has made its way over to BiD. This is the same tool chest. There are the same things in there. When I look at it, it's very freaky to me because I recognize everything in there. You'll also notice this drill press here. I put it on the table late one night. John said, put that up there. I go, okay. But right before I did, I put this little message under it. Hey, you, looked under here. Send me email if you find this message. I left this in 1999. And lo and behold, Ferenc Kovac sent me a message 13 years later that he discovered it. He's very excited about that. And that's when I knew it was time to come back to Berkeley. It was right about the time I was done. So there's other projects that BiD inspired me to build. I did a lot of kind of different robots, different kind of ambulation. I did a project around kind of anti-technology, around creating a kind of electromagnetic pulse, this I-bomb. That actually sat in the building, so that was very disturbing when I think about it now, but it was. Played around with different interfaces and technologies, some nerdy, some kind of dangerous. And then some faculty started to show up. Ken Goldberg. And this guy, right? So he got mentioned many times. So James showed up. I remember his kind of interview here. And that brought on this huge, also kind of collaboration with John and a wealth of students. So we had Mark Newman, who was just a real blast to have around, who's now gone on to be faculty. And here he's kind of wandering around. Sorry, I meant to take some of those out anyway. Also Danielle Fisher, who is here now, is at Microsoft Research doing a lot of work. And then I know Scott Clemmer spoke this morning. Scott asked me to mail a photo to him. I don't know what he said this morning, but I sent him something like this. He goes, oh my gosh, I still own that sweater. He's very disturbed by that. And so I continue to do these other projects on the side, you know. But, you know, with Survival Research Labs, we ended up taking another project which was also built in the lab, which is a vending machine for biological pathogens. More on that later, but it was an art project at Ars Electronica. But it's really the people that I keep coming back to. So really my final days, I ended up meeting some other folks. And I don't know if people will recognize, but that guy is Chris Myers, who now co-directs the Invention Lab, or co-manages the Invention Lab. So I met Chris way back when it was still BiD and I was still a grad student. We were hanging out actually at, that's at the Albatross Bar in Berkeley. Now, Chris obviously does the lab. I know you guys know about the lab. I'm not going to really give you a long story, but for those of you who don't, the Citrus Invention Lab, basically Paul Wright and Bjorn and myself came in to a very sort of bland looking space, and through some great support from Citrus, we're able to build this really great ecosystem. It's about 1,700 square feet. There's a lot of people using the space. And as many of you know, it's often for people to come in and do their own projects, do research, teach classes, and also we have an incubator in there as well. There's a lot of equipment for people to use, and you know, cut and make and do circuits, and you know, more cutting on vinyl cutters, and milling on milling machines, and bigger milling machines for furniture and crazy props and electronics, and a bunch of classes that we've also done, which has been really a lot of fun and made the culture happen. And I know some of these started really back at BiD. I mean, there were some early things where we tried out examples of that at BiD. There's some fellowships that we offer and some startups. So many of you know the Accident Wear, which just became just released. I was walking through the Chicago airport and I spotted this. It's sort of like invented at, you know, the Invention Lab. And then we do these outreach programs. And of course, all this sort of fed into this momentum around Jacobs. And this is another really great sort of, I think Jacobs has a lot of heritage to give back to BiD. And I know Bjorn will say more about that. For me, it's really back to the people, and this is sort of the crew I kind of somewhat graduated with, these folks. At some point I had to go. I got my last signature. Said goodbye to some friends, and even sometimes you have unlikely connections. So even my then girlfriend, but now future wife, hung out in BiD with me lots of times. We like hung out and did things, and it was a lot of fun to have her. And she even went to BiD meetings way back in the day. All right, that's all I've got. Hopefully that gives you some perspective of where BiD has sort of come from and some history. And I just really want to say, I know John's not here, I don't think he's here, but I mean, I really owe a lot to him for many, many things, but he really, at a time when it wasn't considered really something someone would do. He sort of stuck up and said, we need a space to really think creatively and stretch our kind of intellectual and sort of more broad kind of idea thinking. And he created the space that was unlike anything that existed before. It just had a very different feeling. Probably the saddest part was that was right when I graduated. So I never actually had a desk in BiD proper, but I was part of BiD before it had a space. So maybe I get a sticker or something. That's the best I can do. Okay, thanks. Plus it was fun to go into old photos last night.
Eric, did you invent
Well, we only had one digital camera at the time. It took a floppy disk, yes.
So I saw Francesca last Friday at James Landay's trade show. So it seemed to be set up for anything. How do I get out? Okay, well, I feel like I am the wise woman of BiD because I'm going back to 1989, which is where I put the roots of BiD. And Carlo joined me on this. I
mentioned it this morning in my talk.
Okay, I was pregnant with my daughter, who is now 26 years old. 26 years old now. In 1989, they had no maternity benefits for faculty. So they were trying to figure out how I could deliver in March and teach 2 courses in the semester. So I team taught a course called Social Implications of Technology, and in that class was James Landay. He was a student in that class. And then we were going to do a seminar because I was very interested, and the faculty were all getting together, very interested in interdisciplinary approaches to design. And so I could have guest speakers and bring other people in and have a discussion and help define what interdisciplinary design would be all about. And the reason I'm telling you this, going back to this history, is just to reinforce what some people don't realize is the roots of design thinking really stem from Berkeley. So going back to that, I was asked to be the wise woman of design or something by the School of College of Environmental Design to comment on Horst Rittel's original paper on wicked problems, which was published in 1973, followed up in various publications. He was a faculty member at UC Berkeley, and he was part of that seminar that we put on in 1989. So wicked problems are problems that are not solvable. You may do better or worse on them. There's no one solution. They can only be understood if you look at it from a socially complex situation. They require a learning process. They require lots of prototyping and iteration. And you need new design methods, like what we call human-centered design methods, in order to do that. Sound familiar? Okay. And so Horst Rittel's book was written up in Peter Rowe's book, which is the first book on design thinking. And Peter Rowe credited Horst Rittel with, in fact, providing the inspiration behind his book on design thinking. There was a design thinking symposium that was held in 1991. Richard Buchanan had a special issue on design thinking in 1992. And it wasn't until 2009 that the CEO of IDEO, Tim Brown, wrote a book with design thinking in the title. Not to belittle what Stanford and IDEO have done, because they've done great work. Just want to say the roots were at work. So Sarah Beckman wasn't able to join you because of absentee this morning, but just want to say she and I helped develop what we call the Berkeley design thinking model as well for the pedagogy that combines co-learning styles and various iterations going from the human-centered design, observations, research, reframing, insight, ideation, testing, and then going through the cycle again. So a lot of the talks you've heard today already have really gone into this revolutionary way of thinking about human-centered design that BiD inspired and continues to inspire. And is Daniel Lim here? Did I see him walk in? There you go. So here's a great example of that, Sophie's hand, which you'll see demonstrated later on today during the poster session. Woo-Young Kim, did I see? Yes, you were there, you are. His research combines human-centered design trajectories integrated with roadmaps associated with technology and products that he calls design roadmaps. So be sure to go to his poster session as well. And then I'm going to say a bit about recent research that we're doing on tensegrity robots and how we hope to morph these from space exploration to something that has human-centered design on planet Earth. Originally, we started with this project as a challenge from NASA that we needed to deliver a 10-kilogram probe, 1 kilogram payload, 1 kilometer away. And we needed to do it so it was cheap. We could go to the moon or Titan, which is a moon of Saturn. The Mars Curiosity rover, I had been on their advisory board, was like $2 or $3 billion. So cheap is relative, but we thought we could be really cheap. And it has to last for just a couple of hours, deliver the payload accurately, and be able to go over rough terrain, which the Curiosity rover cannot do. So we were inspired by a toy, a tensegrity toy, that also was inspired by another architect that I have learned a lot from, Buckminster Fuller. He coined the term tensegrity, and also there was a bunch of artwork by Kenneth Nelson associated with tensegrities. They're lightweight structures. They can carry large loads, and what's cool about them is they're built from just rods and cables. The rods do not touch each other, so the cables are always in tension, the rods are in compression, and so what you've got is a squishable tensile network that can absorb loads. And so if this works, here is our vision of our mission. So we're both an orbiter, a lander, and a rover. Payload in the middle. So it can go from an orbit or a lander, roll, protect the payload, go to where it's supposed to go for the mission. Okay. Oh, yes. It can go down craters. The idea is it would go uphill, go down craters, 30-degree slope. So cute. Okay. And it can be packed compactly and then open up to a much bigger object. And so as one of the other demonstrations later on today in the poster session, I see Kunam, right? Kunam and Lee are going to demonstrate the tensegrity robot that we have operating, more than just simulation here. And so, for instance, preview. Unless we had it run ever, right? No, we don't need to, never mind. And actually watch it in the demonstration, so I won't do it now. And also, we're finding out that the tensegrity robots are really exciting to kids. And so wherever we go, we have demonstrations, and they're very active participants of it. We were recently on PBS with a special issue on science in which you can create your own tensegrity robot, Black Girls Code. We've also been highlighted in a dance, a choreographer dance, a routine associated with Colin Ho, was a picture in one of your slides, by the way, and combining with arts and technology. We're also looking to the future in different ways then that we can move to planet Earth. For instance, we'll be dropping it from a UAV, first to demonstrate its properties in terms of absorbing impact, but also for search and rescue sort of operations. We're also looking at, well, why do we even need a UAV? Why can't the tensegrity be the flight machine altogether? And as a flight machine, it could go to the air and then it could land itself. So, you know, why have two separate steps? And then this is really our future. We're really interested in how tensegrity robots can be co-robots and work with human beings, because they're soft robots. Most robots are hard robots. They will injure a child if they touch a child. These are cute robots. There are different ways that we can use the tensegrity structure to have limbs or to have a spine. And that's kind of the idea here. And so unlike a lot of robots that have a rigid spine and flexible hands, we want to have a flexible spine and then use that flexibility in the spine just like most mammals have in the system. So that's kind of what I was going to say as the wise woman of BiD. And please go to our demonstrations later today. Yes?
Jane Jacobs had a chapter on rigid problems,
Yes.
1961.
I will add that to my list.
Your reference.
Okay, great. Thank you.
It's, from that
Oh.
All right, I think I'm between you and the next coffee break. So after So-Young's presentation, I looked around and I remembered there were other food projects in BiD before. And this was some kind of cake or cookie decoration mask that was laser cut and sprinkled. My talk's going to be a bit discombobulated since I've mostly been busy with other projects, which is about 2.5 weeks old, so I'm barely back on campus. And instead of making this talk, I was rocking the baby last night. Got a cold from his older brother. So over the course of this semester, we actually had some discussions among the BiD faculty that 10 years, a decade is a great time to kind of rethink what we stand for and what BiD should be going forward. And those discussions are all ongoing, but one interpretation for me of what the letters BiD actually stand for is we're the Berkeley Incubator of Design Programs. And I just want to show you a couple of those that I've been lucky to have been involved in over the last 5 years, but of course the history goes back much further. So first, the Cal Design Lab. So going back to 2010, and this is really an effort kind of started by Laura Olberg, who then pulled me in, and we started teaching the series of design clinics, and we started teaching it in BiD, and we were kind of bursting at the seams. And at the same time, Alice and Sarah started having conversations with Dean Walsh over in College of Environmental Design, and so we were some of the very first occupants, pioneers of the Cal Design Lab space in Worcester Hall that actually had a huge draw from the iSchool of master students who came to attend these design clinics. And so I taught some of them, but really Laura was the brains behind a lot of them. We had critiques there, and you may see a little younger Pablo in this picture. That then also grew into other connections between BiD and between engineering and architecture. So for example, for a year we ran a design theory seminar. Jean-Pierre Protzen was a speaker who talked actually about wicked problems, that UEE and others. And then a couple years later, kind of based on that, on that seed we had placed in the Cal Design Lab, Wendy Ju came to Berkeley for a while and organized a set of workshops. And I was really lucky to get to teach together with Ron Rael in architecture on kind of frontiers in digital fabrication. And so we taught professionals who came back in for a week or two over the summer how to do parametric modeling and how to transform those models into things you could fabricate. And they made lamps and automata, and it was really fantastic collaboration. And we're just right now kind of pulling some of the architecture faculty back across campus to use our new fabrication machines in Jacobs. But it all kind of goes back to the Cal Design Lab in 2010. A second program that we started was the course thread in human-centered design. So Laura also had her fingers in this. And while the Cal Design Lab was, I would say, predominantly used by masters and graduate students, at least in the activities I was initially involved in, there was always many undergrad student groups in BiD, and we were thinking about ways of formalizing a pathway through the vast offerings that Berkeley has in design. And so the course thread was actually a program, and is still a program, offered by the Townsend Center for the Humanities. And the team here was myself and Greg Niemeyer, Alice, then we had Celeste Langen from English, Teresa Caldera from CED, Corey Hayden from Anthropology, and others in a sequence of different conversations and we went through all courses that are open to undergrads that don't have a long prerequisite chain, and identified about 100 that had some bearing upon questions of design and cataloged them. And so now if students take a sequence of 3 of them and then give a presentation where they give a justification why these 3 were a coherent, plan of learning about design, they get a certificate that they exit through. And it turns out about 200 students or so have done this since it was started, and I think it's the largest course thread that was run through the Townsend Center. There's also design bibliography online that we got to do through this, could probably update it by now. And then I was just looking through my photos and I found this, our launch event. So we had Greg Niemeyer, Joe Fish, Kay was one of our inaugural speakers, and once again, Amy Elliott, who seems to make an appearance in every second talk here. So that was the course thread. And then in about 2012, Paul Wright and Eric and I, of course, started the Invention Lab, and it reminded me actually that way before I got to Berkeley, in addition to mostly being a computer scientist and being interested in music, I got pulled into the realm of mechanical engineering while I was a grad student at Stanford. So I took the shop class, got to learn about machining, worked with, again, with Laura and Wendy Ju and others on Ambidextrous Magazine, where we got to take contraptions apart and also build hardware for designers who wanted to build physically embodied products. And so it took me about 2 years after coming to Berkeley to connect back to that. And so in 2012, we said, something's clearly happening in the realm of 3D printed. Maybe we should get one of these for our own lab. But then the very next impulse was, hey, wait a minute. That's kind of the default thing that always happens, is you find a fancy new tool and you buy it for your lab, and only the grad student working on that project gets to use that piece of equipment. And think of any piece of machinery, it's probably somewhere here on campus, but you can't use it. And so one of the main motivations behind the Invention Lab was to have this type of tooling, but make it available to all of campus. And Eric already showed you these pictures. We found the last 2 rooms in Satyajit Hall that the construction crew still had construction debris and leftovers in, and somehow no one else had found them, and within a short time transformed it into what I think of kind of a 21st century workshop, which combines design software, digital fabrication tools, and programmable electronics, and well, also, the other stuff's not yet obsolete. But why is this the workshop? Well, there are a couple of trends that are coming together. The first one is, of course, every computer science talk has some version of this slide, right? Moore's law at work. But then there's a, not Mr. Moore, no one else has yet claimed the name to this law, much slower curve, but we're seeing a similar curve in industrial fabrication equipment coming down in price, getting smaller, maybe being more limited in functionality, but still coming within reach of individuals. And of course, all of this is driven by design software, and kind of what better place than BiD, where we have a combination of engineers from computer science, electrical engineering, mechanical engineering, but all who have a concern for the usability and the interface of these tools to work in this domain. So in the Invention Lab, I think one thing we've been really successful at doing is kind of taking things that a couple of years ago could have been maybe UBCOM research papers, because of this tooling, they're now 10-week class projects, student class projects. So from fixture level water monitoring that is self-powered by a 3D printed impeller that induces enough current to power itself and send its reading off. These, by the way, were Berkeley engineered and then tech transferred to Stanford, where they're now in the dorms. To maybe more whimsical projects that had some real woodworking and welding at its core, like together with Greg Niemeyer and Bob Full, I taught an undergraduate course on interactive seating. And so one student team built this rocking chair that has a pendulum attached to the bottom that then charges a battery while you're sitting and swinging. To teaching tools, here's, for example, the toast board, a better breadboard that measures voltages and signals while you're building your circuits. And so the students really work across the mechanical, the electrical, the CS, and user interface domains in these projects. Other projects for wineries to track whether their batches are fermenting correctly. We've had connections to UCSF on medical devices, step sensing for people with sensory ataxia, or retainers that track whether you're wearing them. So many different projects kind of just exploding in a very short time in the Invention Lab. And then there was a bit of really fortuitous timing. Namely that just as the Invention Lab got going, Paul Jacobs, the executive chairman of Qualcomm, and of course John's PhD student, really wanted to make a mark on undergraduate education at Berkeley and made a large gift to the College of Engineering. And then luckily that then led the college to look around for what are possible role models of instruction that could be housed in the new Jacobs Institute. And there are a couple of very successful visits to the Invention Lab that then led to, the Jacobs Institute is doing a lot more, but certainly one of the functions it's fulfilling is kind of scaling up the Invention Lab model to a much larger scale. What then was really fun after that gift was announced, I got to work with many people in this room. Carlo, of course, who has vast experience designing half of this side of campus. It seems like by now, and Alice and John, who convened a group of faculty coming up with rough sketches for space usage in Jacobs Hall. That was the summer of 2013. That then flowed into a process with the architects, who then made interior renderings and exterior renderings, and it all looked already really polished on paper in 2013. But the reality, of course, was this. It took a whole lot of time to dig a very deep hole. Then it took another long time to fill that deep hole back up with concrete. And Carlo has documented this. You should go to his webpage. There are hundreds of pages of how Jacobs Hall came to be. January 2015, we're now, so it took quite a long time to get out of that hole. And then there was a single week in February that was really amazing if you were a Soda Hall occupant and you looked out onto the former volleyball court. Here's a time lapse from that week. Where basically, in the span of 1 week, all of the steel for the building went up. And so we had the traditional topping out ceremony where you place the last beam just this February. And we all thought, well, now the building's almost done, right? Of course, that's not quite the case. It took another half year to put all the services, infrastructure, and everything out. And this is what the building looked like 24 hours before it opened. So we opened August 20th. Yeah, Oski came. So we had real celebrities. And then we promptly closed it again on August 21st to let the construction crew finish their job. If you go in today, you may still find some of them roaming the hallways. But the building came together really rapidly, and so if you haven't visited, you should stop by. Basically, after the coffee break is a great time to see some poster presentations of the first set of classes in Jacobs Hall. There also tomorrow, all afternoon, there'll be presentations from classes. And so there are 3.5 floors, and I think what I'm really proud of, what we managed to do is not have any classes on the first floor. It's entirely drop-in space for students who are working on their own projects, on student club projects, on class projects, on their next startup idea. And I was a bit incredulous at these statistics, but people counted multiple times, and actually already over 1,000 students made their way into Jacobs Hall just in the first semester while construction was still ongoing. Of course, many of the courses that the PIs here teach are in Jacobs Hall, but there's also, which I think is really interesting, is we now have the resources and the will to staff introductory courses for undergrads in kind of core skills and concepts. So design methodology, prototyping fabrication, visual communication. There'll be others added to that list in the near future. Design.berkeley.edu is the website there if you want to find out more about it. And I think with that, I've exhausted my 15 minutes, so I'll leave it right there. Thank you.
I remember as a grad student looking into design.berkeley.edu for years. Who had it this whole time? You know, the student council on Berkeley innovation.
Yeah,
someone was sitting on it, and it was and they would tell us who it was. And I was checking since like 2010.
They hinted in 2009 that it was architecture, but they never put a website there.
Yeah, it was, someone was
I think it might have been in the life sciences lab.
oh, I got it. That's like solid URL right
No, that's a good point. I think your new acronym for BiD, it also inspired lots of other things. Connecting for innovation, the design for impact, and running concept as well.
Yeah.
To claim those. Although Berkeley innovation predates BiD, but they were evolving.
There was certainly BiD was their home for many years, yes. And now they moved into the top floor of Jacobs Hall. I think we pretty much fill that room right now. Yeah, so we have some right here. Yep. Yeah, I just picked 4 that I knew well of because people involved with. But yes, I should maybe make a list of all of them. All right, thank you. Then let's consult our schedule here.
CS160 projects.
At 2:30, Laura, Jitao, and Greg will talk here.
Okay,
so we continue here. Okay. And the Jacob's presentations are also starting now, but they're running for 2 hours.
Mine over there. Just with them on the second floor. They're
Oh, okay, all right.
It's just like sometimes I like
You will, yeah, you're around. Well, so just keep, so
I was sprinting up the hill to like get to my house.
you know what?
I know. And that was it's the best thing. I was stressing out so much. Yeah, they're running. Every class I want to write down. Sorry.
And everybody else can watch the webcam. And so they have like rooms around campus where students like that. So we're in another.
Madam, watch video offline.
Yeah. I'm going to grab a copy.
And then I know that
Yes, we'll have a safe like that. Let's make it roll. And then, yeah, let's go over there. Yes. So this should be.
Is there another? Okay.
Oh, yes.
Oh, yeah. What is that?
So look at the oh, you oh, I'm still a student, so I'm not undergrad. I agree. This was amazing. My research if we were to move to a company with license back, and otherwise it's also So how are you able to tell
Yeah, that's like way more.
Right, yeah.
So unlike some sort of musicians who
I'm gonna send you some.
Oh, interesting. Yeah.
I'll tell you. Hello, everyone in Video Land and in the room. Let's reconvene.
Grab your sugar, grab your caffeine.
Great. And starting us off in the last session for the afternoon before we break for posters and demos and Jacob Saw. It's all over.
Hi. So yes, if we haven't met yet, which we will soon. My name is Laura Olberg. I was here, well, I'll show you on my timeline very soon. I'm currently at the University of Calgary, where I'm an assistant professor in computer science, which also means I get to supervise students in their computational media and design program, which is super cool. I'm part of the Interactions Lab, which is a set of about 6 or 7 faculty in HCI. My group is the Curio Lab, and I'll be giving a brief talk today. If you're going back to ancient history, and if you're a new person, this is my current street cred that I have at Berkeley. If you don't recognize me, you might recognize the other person in this picture, dressed as a pirate, which is a heavy clue. Because it's this guy you might recognize. And if you still don't recognize this guy, you've probably seen him in the Invention Lab a fair amount. So I am Mark Olberg's little sister, or he is my older brother, because references go both ways. He recently left, but if you might know Mark, I sort of come from being Mark's little sister, which means having him explain things to me since I was little, which is probably part of the reason I ended up the way I did. So in the grand timeline of things, before I was at Berkeley, I was at Stanford doing my undergrad in mechanical engineering. I actually took Scott Clemmer's HCI research methods class. I worked with Bjorn and Wendy Zhu and that whole side of people. I then came to Berkeley, where I was part of the Berkeley Institute of Design and the Berkeley Expert Systems Technology Lab, which is Alex's group. I did my master's and PhD. Then went to INRIA in France to do a 2-year postdoc in the In Situ group, which is a HCI research group, and I'm now at the University of Calgary. So my master's research, I'm sort of your more standard design researcher. I study how design processes work, so I kind of started out with this massive interest in logbooks and design journals, which was great for my master's, but then there was something that was kind of missing, and that was, well, we've got these design journals, they're sort of rich, but they're not just analog. We've got people taping physical stuff in these journals. We've got people using digital tools to author pages, and they're doing things like printing out photos and then drawing on top of them. So it's really a mixed technology, mixed media kind of thing. And then for my thesis, I became more interested in sort of the social implications of this type of technology. So not only how individuals are using these design journals in multiple media, but how that then is passed along to the rest of the group. And how the rest of the group interacts with each other to share information through visual media, digital media, and physical objects. So for my thesis, I did a lot of field work looking at student design teams, looking at how they communicated during user research and conceptual design meetings. This led to the design of Dazzle. So the concept is that you have a bunch of people with individual information. This gets shared as the team, but by showing it to others on a large display, which implicitly shares that information to others and keeps a record of sort of what's in the group's, and that resulted in a built system. And we did a couple user studies looking at how people would interact with the system over a series of meetings. So both looking at user research and how that later informs conceptual design. I now sort of define myself as someone who researches how technology supports collaboration, creativity, and curiosity. Methodologically, I do this through qualitative research on design teams, which is sort of to my design researcher core. But then I also do design-based exploration via interactive systems. So I'm going to quickly go through 2 sort of recent projects. Oh no, my author was going to that. One is the supporting the design and fabrication of physical visualization. So this was a system called MakerViz. I worked with some information visualization researchers looking at how to bring tools that would allow people to author physical visualizations of their data, given that they might not necessarily be that great at either data management or fabrication. So it's this tool that bridges people who might have a CSV file with tons of data points and actually authoring the thing, creating a printable file or a laser cutterable file that you can then build. So
Software itself is over here. Using that to sort of specify what data dimensions you're interested in, how you'd like to map that to physical dimensions, and then sort of fabrication specifications. Person then goes, actually creates it, and then assembles their, in this case, 3D bar chart. Another piece of work that I did recently was looking at patterns of physical design remixing on online maker communities. So most specifically, Thingiverse. So Thingiverse is one of the, debatably, largest collections of 3D printable objects on the internet. And so basically, and one of the core functionalities of Thingiverse is there's the ability to remix from each other's designs. And this has been a standard feature since 2008. What I did is I scraped all of Thingiverse, so my data is as of sort of midsummer 2014, and then looked at all of the remixing connections. So who's borrowing from whom in the world of Thingiverse. We found a couple interesting things. One is that Thingiverse had a new customizer feature they introduced in 2013, which resulted in a totally different type of remixing than all other remixes. You can talk to me about that later, but the other thing we found is that it's not just 3D printable objects that are being remixed and shared. It's the sort of concept of design tools and techniques, what you can do with design and apply them in different ways. So over here in the corner, we have a laser cut hinge. So someone posted this as, hey, I've got this idea for a laser cut hinge. Results in two types of remixes. One is applying that same hinge design to a new form, so in this case, a business card holder, or thinking about exploring that technique in itself. So on the other side, we have someone who sort of made different patterns to look at how flexibility can be expressed in new ways using that sort of core concept. If you want to talk to me more about research, catch me during the poster session or later. I actually figured I would talk a bit more about how do we sustain design communities. I was pretty involved as a graduate student, I think is a pretty good understatement, which has served me very well. And in my experience both in Berkeley and in France and now at Calgary, I've taken the past couple of days to think about how do you make this system work? Because it takes work, and what's more important than just building a design community is making one that actually lives for, say, 10 years or more. So things that I think are important. So first, share responsibility, ownership, and credit. If this sounds terrifying, you might recognize this from design teams. So I taught a ton of design courses while I was here. Thanks, Alice. It was a great opportunity. So freshman design, upper division, undergraduate product design, graduate level product design, sustainable product design. When you've got teams working together, you can't just have one person who decides they own the project and they run with it. You have to have some sense of shared ownership, shared buy-in from people. The reason this is important for communities is because beyond your time, it can continue to live because it was not you that was important. The idea that's more important, and it can continue to sort of propagate onwards. Examples of this in practice at Berkeley. One was the prototyping design clinics. Bjorn gives me credit because I was very loud, but it was me, and it was students from our 290p class who actually approached me saying, this is an awesome class, I wish I could keep learning. So what I did is I recruited Bjorn, who will last beyond my years, and I recruited these students who obviously have the desire to make this last, and they have their student organization to propagate it forward. And did some matchmaking to make sure that it's not me who did it, it's actually a combination of these other forces who do have buy-in and who are also invested in this idea. Same goes for the design decal. I have no idea if it's kept the crazy punctuation. Has it kept the crazy punctuation with the curly brackets? Apologies for the punctuation. But that was a sort of joint effort between Berkeley Innovation and myself because I was sort of acting as their guardian angel. And they were struggling with this problem of constantly spending all of their group meetings reteaching design. So you would be a long-term member of Berkeley Innovation, but not feel like you were accomplishing anything because you kept on going back to the core principles. So by externalizing this and spinning it off into a decal, it gave others sort of an easy way to enter into this idea of like, maybe I'll try out what it's like to do design, and if I like it, I'll stick around for Berkeley Innovation. Or if you're new to Berkeley Innovation, you can take the design decal. the nice thing about this is that it's once again a shared responsibility, shared ownership, and shared credit. So I can kind of take some credit for it, but really it totally goes to Berkeley Innovation for making sure that this stays for a longer period of time. So it's sort of
You're running at 40 to 50 students a semester.
Which is great to hear. And it would not be like that if I had claimed full ownership and said, sorry, I'm graduating, this is dead now. So by making sure that I am not critical to that system means that it can live beyond me, which means, you know, sharing and trusting others, which is scary, but very important. Next thing, invite everyone. It's really easy to get caught up in academic silos. Design does not fare well in silos. Your best bet is to make things as open as possible and be as generous as possible with what you know and what you do. Once again, the decal and the prototyping design clinics were great examples of this. We did not care if you were from Rhetoric. We had an instructor in the design decal from Rhetoric, and she's fantastic. Her point of view on design was totally different, and she was able to sort of communicate design to a humanities audience in a way that's really incredible. Prototyping design clinics sort of started out as, you know, lots of students from the iSchool, but it's sort of inviting them to really anybody to come in and learn these types of skills. I totally forgot about the course thread, but that's another great example of inviting everyone and trying to make it possible for anybody to contribute. Another thing that I'd like to point out is it's inviting everyone. You can't just build it and they will come. Making sure there's an explicit invitation so that you're saying, yes, please come to this, please be a part of this, is a lot of what's important. Sort of as a side note, I sort of saw the impact of having a smaller community when I was in France. So this is me. I taught a couple semesters of creative design to this human-computer interaction and design program. It's a master's level program with about 10 to 15 students in it. And that was it. At this very small, small program within a university outside of Paris, but there was not necessarily an everyone to invite. It was a little difficult to find the everyone. So if you're in a position where everyone is there and you have people to invite, by all means invite them. The other thing that I think is sort of hilarious is this is what's happening right now. That's the Jacobs Winter Design Showcase. I dug this out from my email. Back in 2011, I had Design Fest. I have never been good at naming things, but it's not bad. And this was an idea that I had mostly because I was so frustrated with all of the different places that design was happening on campus that didn't necessarily talk to each other or meet each other, and you'd be going from one trade show to the next. So why don't we just invite everybody, invite the public, invite everyone's friends to come. And doing this makes it so that it's easy to see where design can take you. You can see the breadth of design that's around and encourages more participation. Third thing, Louis Bucchiarelli was the first design researcher to sort of admit that designers are people and we can study them like we study people. But from a community perspective, designers are people. They're not just, you know, automatons that do creative stuff for a living and then go home to their like coffin and sleep and wake up and do more design. They're people with lives and families and friends. They eat, they have fears, they have things that they really enjoy that have nothing to do with design. And recognizing that is really important. This is actually a project that I worked on while in France. In France, the joke is that going on strike is a national pastime, kind of like baseball. And so our Trotskyian communist cafeteria would often go on strike. And when that happened, there was nothing to eat. You'd have to hop in a car to go find something to eat. So it's actually an idea I started out with back when I worked at Tanko. We also had sort of a food desert where we were working. So we had Salad Club. This is our Salad Club from France, and it was a very easy concept. It's a spreadsheet, and you just say, hey, here's a recipe, sign up for an ingredient, bring it on Tuesday. And all it took was a spreadsheet. And by inviting people to do something like Salad Days, we would have research conversations about this. You would find out what people do and don't like as food. We would have to do this because the cafeteria was closed. But now, actually, at Calgary, I started doing this again. I've, once again, set it up and then gently pushed it to the students to continue on. And it's a great way to bring people together as people, not just as, oh, we're all researchers in this research lab. It flattens relationships. You've got students talking with faculty, talking with staff, because you all eat, you're all people. The other sort of designers are people, it's not the best picture, but this is actually from BiD 2013 when it was in Paris. The information visualization community has a subgroup who really likes cycling. And I was relatively new to this community. It was my first BiD conference. And I signed up for the Tour de BiD, which is a, what was it, like 70-kilometer bike ride after the conference. And it was amazing because you end up talking with super senior researchers at the University of Utah who are like pioneers in the field, kitted out in spandex, and you're riding through Versailles, and that's who this person is on the weekend when they're not, being, super impactful in their field or teaching classes. They're a person who just really likes biking, and you can connect with people in a very different way. So offering opportunities to be a community of people, not just of designers, is very important. My last one is radiate love. And that's Alice. There's a lot of people who are very important to me. Alice is like the best example of how to radiate love and build community. So much of her work has to do with broadening the conversation, generally broadening the conversation in design. So let's not just think about design as mechanical engineering in my tiny little silo. It's like, let's think about mechanical engineering, and other kinds of engineering. Well, yeah, computer science too. Business is really important. How can we think about the humanities? And it's really building a conversation that's broad and communicating both humility and your own expertise to really know how that's done. The other thing is involving more people in design and doing so in a very loving way. So let's explicitly reach out to people with different genders and ethnic backgrounds and socioeconomic backgrounds, and people from, since I'm in Canada, First Nations and Native American tribes to all participate in this conversation, and really thinking about how to make the world a better place without necessarily letting your ego take control. Actually, one of my favorite Alice stories is when Alice was put in charge of the prelims committee in our department while I was there. Her first instinct was to go to the graduate student organization and say, hey, they just gave me the prelims committee, how should I make things better? And that was her first thought. It was not necessarily, how do I do what's the most stable? How do I do what's easiest for me? How do I not make more work for myself? It's really this idea of saying, how do we make things better? And letting that be your guide, as opposed to trying to focus on your own career or your own interests constantly. So Alice is a great, if you want to know how to do this, just watch Alice and try to do what Alice would do in any situation, and you will probably be on a good path. So with that, this is my new backyard. It is beautiful up and down. And I'm up in Calgary, so come down and say hi. We can go skiing, or we can go hike in the mountains. It's awesome. Cool. Questions?
Yeah. Is there any part of your community thing that you think doesn't apply to every community? Because I feel like if you replace the word designer in your rules with community member,
yeah,
it feels.
Yeah, I think
I was replacing everything in my head with judder, and I was like, I feel like this could work.
It totally works with judder. I think part of what for my full list, I think part of what it comes down to is that when we think professionally about what it means to be a designer, I actually have a whole rant on this. There's a nice balance between confidence and humility. As a designer, you have to have sort of a cocky amount of confidence to say, I can totally solve this problem. I have the expertise that is needed in order to make things happen. Ideally, you also have the humility to acknowledge, I have no idea what's going on. I really need to get some people to help me out and to figure out what the right thing to do is. So I think here, part of the fine line that we're walking, and part of it needs to be expressly acknowledged, is that there's a lot of humility in design. Humility is key in design. And it's a good reminder that community comes from humility, not necessarily from having a big vision and then dragging along everybody else with it. So I think in design particularly, this is actually a good thing to remind yourself that designers are people. Everyone should come along, we're great. We can all take credit for this, it's wonderful.
Is there much of a design community up in Calgary, or do you find yourself having to mostly deal with people in other cities?
So within HCI, so I still need to crack the mechanical engineering department. There's a lot of petroleum industry, for better or for worse. However, there's also a lot of provincial support to get away from the petroleum industry so as to not just be dependent on it solely. So the medical innovation community, I've been put in touch with them and been sort of tasked to go figure out what's going on there. In human-computer interaction, there's two very senior researchers, so Saul Greenberg and Sheila Carpendale, who've been there for probably, I don't know how many years, 15, 20 years. Saul just got like a lifetime achievement thing at WIST for stuff he did in 2001, but he's been around before that. So within HCI, very like long-standing group there. There's a lot of enthusiasm, there's a lot of investment happening. But yeah, it's interesting to juxtapose it against the Bay Area where it's just bigger, like physically bigger in terms of the number of people and the number of things going on. Cool. Any other questions? I pass the torch. Okay.
All right, let's get started. My name is Jingtao Wang. I graduated from Berkeley in the year 2010. I was fortunate to be the first batch of PhD students when BiD was founded. And Eric graduated before I came to Berkeley. I came to Berkeley in the same year as Tara Matthews and Jeff Keir, and Wes, Andy came after me. I have been a faculty member in the University of Pittsburgh for 5 years. What's unique about me is I have a joint appointment in both CS and LRDC, which means Learning Research and Development Center. The Department of Computer Science has 20 tenure-track faculty members, and the LRDC has 30 tenure-track faculty members. What's unique about LRDC is it's an institute focusing on education. But most of the faculty members have background in educational psychology, education, social science, etc. I'm one of the 2 faculty members among 30 faculty members with a background in computer science. And this is my group homepage. It's MIPS, which means Mobile Interfaces and Pedagogical Systems. This phrase summarizes my primary research directions nowadays. And this is a picture taken in the year 2013. Here, Andrew Head. He worked with me as an undergrad student and joined UC Berkeley as a PhD student. And this is Xiangming Fan and this is Xiang Xiao. They were first 2 PhD students of mine. Both of them passed their proposal defense last month and are planning to graduate next year. And this is a summary of my research directions. I work on mobile interfaces, education technology, and end-user programming. Here, end-user programming means that I design tools to facilitate, for example, educators or doctors to make them more productive rather than replace them. Here are some projects. For example, this is a mobile interface project with source code released, which converts the back camera as an input device. And many people download source code and build follow-up projects on top of that. And this is another pretty interesting project. It's about designing serious games. By playing the game, it can monitor your heart rate implicitly in real time. Again, source code available. This game can make you fun and make you a little healthy by playing the game. I also design algorithms to be able to collect and analyze physiological signals implicitly. Here, physiological signals could be, for example, heart rate signals. We can infer such kind of signals directly without modification to mobile devices. I design algorithms to make it possible. As I said, I also build tools to help, for example, in this case, doctors or physicians to make their work more productive. This is a medical clinical learning building system to make it easier for doctors to explore and design clinical algorithms. And this is a visualization interface to help educators, in this case, teachers who are using peer review to scale up teaching, to understand what's going on in the peer review critiques collected from hundreds of students. I also designed tools to make it easier for researchers in psychology, cognitive science, etc. to design domain-specific experiments running on mobile devices without requiring them to learn how to program Android or iOS devices, etc. Today, I'm going to focus on one of the directions, that's mobile learning. And I want to illustrate that it's possible to design engaging and effective mobile learning systems by combining modern pedagogy and compelling mobile technology. The project I'm presenting are collaborative work with faculty members and students at the University of Pittsburgh. This picture shows the latest iPhone 6s. If you combine the computing power of both its GPU and CPU, it's about 130 gigaflops. What does that mean? If you look back, this is one of the supercomputers back in the year 1993. It's only marginally faster than the combined GPU and CPU power of today's mobile phone. It means that, essentially speaking, if you're using an iPhone 6s, you have a supercomputer in your pocket. That's really great. At the same time, I like to, this is one of my favorite quotes. This is the best of times, it was the worst of times. We have a supercomputer in our pocket, but we also face unique challenges. For example, higher education enrollment are increasing steadily, and we are seeing larger and larger classrooms in undergraduate level education. At the same time, almost every state is experiencing large budget cut on education. And I'm pretty sure that everyone here can share many stories about budget cut, funding cut, etc. Can we leverage, for example, the supercomputer in our pocket to make things a little bit better? Before we get started, I'd like to share with you two real-world stories. This is my daughter. She's 11 years old. She was born when I was a PhD student at Berkeley. She's now a 6th grade student in Inglewood Middle School. This is one of the best middle schools in Pittsburgh region. The rating was 10 out of 10. I received her grade report card last month. And on the math report card, it says she received 100 out of 100 for all the homework assignments. In math, I was really surprised and excited. I asked her, wow, you're doing amazing work. It's a great achievement to have perfect grades for your homework assignments. Guess what? She replied, not really. The teacher will give you 100 out of 100 as long as you submit the homework assignment. I asked in the family visit, I asked the teacher, is that true? You give the students 100 out of 100 as long as they just submit the homework assignment? The teacher said, yes, for two reasons. First, because of the budget cut, we cannot afford to grade homework assignments. Second, the teacher argued that isn't that motivating to let the students knowing that you have perfect grade for your homework assignment. I didn't argue with the student, but I thought, really? Can you really motivate students by giving them 100 perfect grade, no matter what they did? It only motivates them to submit homework assignment, not work hard on the problems. And here's another story. It was about a professor in University of Washington called Cliff Max. There was a researcher in Stanford called Cliff Max. There is only one category difference. And she teaches undergraduate level STEM courses. And in one of the courses, he gave some entrance exam to fresh undergraduate students in University of Washington. And here are some of the questions. These are just basic math questions. For example, this question means, what is 1 divided by 0.1? Here's another one. What's 2 powered by -2? And what is cosine alpha? These are some pretty preliminary questions on maths. They were given every year to fresh undergrad students in engineering at the University of Washington. Guess what? Here are the summarized performance. Only 70% of students can solve 1 divided by 0.1. And 50% of students can solve what's the negative power of -2. For the definition of cosine alpha, it's again about 50%. So as you can see, there are major challenges in education, even for one of the richest and well-educated country, the United States. Here comes the questions. And I think, so here comes the question. Can the supercomputer in your pocket help us to learn more effectively? And I argue that it's possible by taking into account advances in both pedagogy and mobile technology. I draw this chart because I identify some of the limitations for today's approaches in mobile learning. There are some mobile learning systems built by researchers with a background in education. They were backed up by sound pedagogy, but the interface itself was not engaging enough to motivate students. At the same time, we also see, for example, some of the mobile learning systems created by researchers with a background in computer science. They have good sound effects, animation effects, but according to a recent study, it didn't really improve learning outcome. So I think there are some opportunities by taking both directions into account, taking both pedagogy and state-of-the-art mobile technology into account to design engaging and effective mobile interfaces. This is what I'm trying to do now. And I argue that it's possible to design effective and engaging mobile interfaces by pushing the envelope of those two directions. And here are some of the pedagogy I explored. Some of them were pretty common, such as gamification, and I just want to highlight one of them, which I think it was largely ignored by today's researchers in education with a background in computer science. That is metacognition. What is metacognition? Which means that it's an implicit decision in the learner's mind every time when the learner is exposed to a learning task. Before the learner uses your system, they will make some judgment, for example, ease of learning judgment. Is this task easy to learn or not? If not, most likely the learner will procrastinate, like working on a research project he or she is not interested in. At the same time, it will also be judgment of learning. Will working on this task really help me to learn something? And retrospective confidence judgment. After completing this task, did I really learn something immediately? If any of the answer to those questions was a no, then the learners were least likely to use the learning system efficiently, even if you design in the format of a game, etc. To illustrate this idea, here is one of the learning systems we designed. It's called TuneWorks. The basic idea is to connect native speakers with second language learners in a game format. It's easy to learn because it's a game. It takes you only 1-2 minutes to figure out how to play it. At the same time, we can see the outcome of learning by competing with native speakers. You may not be able to have better language skills with native speakers, but you could be as good as native speakers for a couple of words, a couple of phrases. By clearly knowing that, the learner will be motivated by such a task quickly in every session. And this is the argument I want to make in terms of metacognition. Here I like to give you 2 additional examples. One on how to use mobile learning to facilitate large classroom education. Another one was how to use mobile learning to facilitate MOOC learning. I think such a screenshot is becoming more and more popular nowadays with the budget cut, with the increase of student enrollment. When the size of classroom increases, interactions between students and instructors decreases. how can we increase the interaction will actively involve both instructors and students in the learning process. Again, we want to leverage advances in both pedagogy and mobile technology. I think one of the pedagogy we can take advantage of is called reflections. Reflection technologies such as reflection prompts, multi-cards have been widely used by researchers in education. It has shown effective outcome results on improving learning outcome. The idea was asking some questions to students as in the format of a multi-card. Ask them questions such as, what's the most confusing problem you have encountered in today's lecture? And here are some additional examples. The reflection question could be backward looking, inward looking, outward looking, forward looking. And then after the instructor reviews input from students, the instructor change and address some of the problem identified from reflection prompts in the next lecture. This approach has been proven by researchers in education. At the same time, when we really use such a technology in large classrooms, there are at least 3 challenges. First, administering such kind of reflection collection is pretty time-consuming. Second, it's also time-consuming for the instructors to make sense of the student reflections when the reflection comes in hundreds of pieces. And last, sustaining students' motivation for high-quality writing and deep reflection is also difficult. So we have designed a mobile learning system called Course Mirror, which means mobile in-situ reflections and review with optimized rubrics. And it's available at coursemirror.com. We leverage natural language processing and intelligent user interfaces to address those 3 challenges. Here is how it works. Once the instructor enrolled in Course Mirror, we load the course schedule into a backend server database. And every time after the lecture ends, we send a push notification directly to the student's mobile device. And the student can click on the push notification to submit reflection to today's class. The questions can be customized by instructors. And we run server-side algorithms to automatically summarize the student reflections. And we emphasize both the importance and the diversity of student reflections. In this way, we addressed the first challenge by making the whole process automatic. At the same time, we also address the second challenge in terms of understanding the reflections by leveraging natural language processing algorithms. And for the third question, how to motivate learners, we again leverage both intelligent user interfaces and natural language processing. The basic idea is the students must reflect deeply in order to have a good learning outcome. To reflect deeply, in a physics class, the student shouldn't just say what's in terms of what's the most confusing point. The student shouldn't just say unit cells, because this is a simple repetition of a term mentioned in the lecture. Mentioning that is relatively generic. It's not deep. In comparison, how type of the crystal structure affects strings of material is a deep reflection, because it not only mentions a term you learn in the classroom, and also mentioned why it was confusing. And inspired by such kind of work, we have defined 4 types of reflections: non-weak, general, and specific. We design algorithms to automatically classify student reflections and give them real-time feedback to help them to write deep reflections. Here is how it works. When the student was first asked questions such as what's the most confusing part, if the student answers something like nothing, it's apparently a non-reflection. We provide quality feedback and suggestions. And if the student answers something, the whole lecture is confusing, we also give them some additional suggestion on how to improve detect and improve such kind of reflections. And if the student just mentioning a term, we see that this is a little bit generic. We allow them to provide a little more details until the student could answer something like this. Not just a reference of a term, but also why this term is confusing, etc. And so here is an overview about the challenges, and here are how we address those challenges. And we have 5 deployments today in real courses. 2 of them are graduate level courses, and 3 of them are undergraduate level courses, with more than 300 students in total. And here are some of the outcomes from one of the lectures. We have 79 students in the controlled condition and 74 students in the intervention group, and we found that course mirror can significantly improve the learning outcome. And we also found that students are willing to submit reflections on a timely manner. And subjectively, the students also lack using course mirror. And here are some quotes from students. And this is the website. And the mobile app is available for both iOS and Android platform. All right, so the second project I'd like to mention is called Attentive Learner. It's designed to improve mobile MOOC learning. And it received the best paper nomination from ECM ICMI last month. And everyone knows that MOOC is really big. And the MOOC technology can not only be used for MOOCs, it can also be used to improve traditional classroom by flipping the course, letting instructors focus on what's unique in a traditional classroom environment. And the major MOOC providers are also providing mobile apps to make it easier to let learners use their fragmented time for MOOC learning. At the same time, there are also some unique challenges in MOOC learning. For example, learners in MOOC are more likely to be disrupted when they are studying alone. Second, there is little personalization of instruction. And third, most importantly, we lack a direct, fine-grained, and immediate feedback channel from learner to instructors, because teaching and learning happen asynchronously. And there are already some existing technologies, but most of them focus on clickstream analysis. They will actually analyze students' interactions rather than their learning process. At the same time, those clickstream analysis were largely highly delayed, coarse-grained, and indirect measurements. So here we propose a system called Attentive Learner to improve MOOC learning by collecting implicit heart rate signals on unmodified mobile phones. We believe that 1 minute of physiological signals is worth maybe 1,000 mouse clicks. And here is how it works. We convert the back camera as the play button of mobile app. When the user is covering the back camera, the video is playing. Uncovering the camera will pause video. And we also infer learners cognitive, extract learners physiological signals from the fingertip transparency changes. And here is the architecture of MOOC Learner. It can help both instructors and students. And it can provide a fine-grained direct feedback channel for better understanding of learners. It can also, it's also an engaging and intuitively used MOOC learning system. And most importantly, it can provide insights from physiological signal analysis to benefit both instructors and the learners. And here are the 3 major components of Attentive Learner. It includes tangible video control, implicit PDG, which is photoplasticography tracking and cognitive state influence. We can infer learners' cognitive states in learning. And here are some of the existing efforts in terms of tangible video control, implicit PDG sensing, and cognitive state inference. And by leveraging the outcome from those 3 components, we can help both instructors and learners. And more importantly, this system provides us a scalable channel to understand learning from a different perspective. By understanding the dynamics of affective states of learners, and also explore the use of cognitive state-based intervention technologies. First, I'm going to talk about tangible video control. I'll talk about algorithm design and usability. And the finger covering detection was based on an upgraded version of lens gesture. It can detect whether the user is finger covering the lens or the surface blocking the lens, and only play the video when the user is finger covering the lens, and we can achieve extremely high accuracy. And this channel is also pretty efficient to use when compared with the touch channel. It's only about 170 milliseconds slower, and learners also found it's pretty comfortable to use a tangible video control channel. For the signal sensing, and here is how it works. When the heart pumps blood to the fingertip, the fingertip transparency will change, and we can infer learner's heart rate from the fingertip transparency changes. And we also design algorithm to extract heart rate from extremely noisy and intermittent PPG signals. And we run user studies to monitor learners' physiological signals when they are taking more courses. And the learners found this interface intuitive and easy to use. And the quality collected from this process is also very high. More than 80% of the signals have pretty good quality. And battery life, it can last more than 2 hours and 31 minutes when the flash is on, and we can even have better performance if we optimize the video playback and switch to hardware-based encoding. And for the cognitive state inference, we explore the feasibility of boredom and confusion detection and divided attention detection. And here are some of the experimental setup in the case of boredom and confusion detection and divided attention detection. And here is the workflow. We use a moving window to analyze PPG signals and feed the parameters efficiently extracted to some of the prediction models and predict learners' cognitive states. And here are some of the features we use. Here are the performance. We could achieve comparable performance when using dedicated sensors such as ECG, EMG sensors.
Now I think you might be running.
Yeah. Another important thing worth mentioning is that how can we leverage imperfect predictions on learners' cognitive states to get tangible improvements on learning outcome. We identify there are two approaches. One is to predict extremely personal learning events. That is a portion of the learning events that change drastically when compared with normal PPG signals. Another one, and we can significantly improve the prediction accuracy this way. Another one is to aggregate learning outcome. And here are in sync with some of the lecture content. For example, here are some of the subject-reported outcome on lecture boredom. Here are the predicted ones. Once we aggregate the results, we can get much higher accuracy. And here is the homepage, and here is the summary. And I want to use these two examples to illustrate that it's possible to leverage both modern advances in modern pedagogy and state-of-the-art mobile technology to design engaging and effective mobile learning systems. That's it. Thank you.
Question? Yeah, have you considered using the front camera of the phone? Because then you could probably do things like eye tracking or check pupil dilation, which has been shown to correlate very closely with whether someone is thinking
we have some ongoing projects using front cameras to keep track of for example, lens eye gaze direction. And we can even extract heart rate from facial image changes. But again, it has even more noise when compared with fingertip transparency, because you cannot control the environmental illumination conditions. At the same time, the front camera may not be pointing at the your learners face directly. Yeah. But again, those are some weak signals. It can serve as supplemental channels to help us to understand the learner's learning process better.
Cool. Thanks, Jingdao. So, yeah, we have our last speaker on the regular schedule. It's Greg Niemeyer from Berkeley Art Practice, who's been a collaborator with BiD almost from the beginning, I think. One of the early tenants anyway, and continues to do a lot of interesting things on the borderline between technology and art.
Yes, thank you so much. Good afternoon. I hope you guys are not too exhausted yet. It's been a long day. You've been sitting in these chairs for an amazing amount of time. I just want to say thank you, BiD, because about 7 years ago I did a sabbatical and I come from art practice and I did a BiD. And I learned so much and it's still going on. While I was sitting here, I was changing my slides at least twice because of your talk, Laura, and your talk, Jingdao. And I just was thinking a lot recently about intrinsic and extrinsic motivation, especially as it pertains to education. So intrinsic motivation is something like curiosity. And the amazing thing about the BiD Lab is that people come together, and in that space, there is a feeling of joint exploration and a feeling of curiosity that brings us together, and not one of competition. And I don't know how you do that. Maybe you have a secret, John, but that feeling of fostering intrinsic motivation is really important, because a lot of times in education, we actually reward people for learning by giving them grades. And when we do that, we give them extrinsic motivation, and that actually is shown to decrease intrinsic motivation, such as curiosity. And so following Jintao's presentation, I have to say that sometimes things are boring and sometimes things are confusing, and we should ask not only how does it look, but also how does it feel, and how could we create experiences and environments in which people are driven by their own intrinsic motivation to explore more. And if we do that right, we go to a space of lifelong learning and a state in which we master ambient challenges, integrate new experiences, and configure a coherent sense of self. And that is so fundamentally different from the kinds of metrics that we often find in education, but to me, profoundly exciting, that we never stop because we want to, from the inside out, learn about the world, rather than being told that we need to know more things. And so that's been framing a lot of conversations. I'm also particularly interested lately in how information makes community, and how we are intrinsically inclined to find out stuff from each other. When we do, we often configure new kinds of communities. So right now we're in a group here and we're sharing information. I missed some of it, but I'm speaking now, so I'm the yellow dot, right? And I share some information with you. Then one of you will go somewhere else. So one of your friends is somewhere else and is studying something else, and is in a different kind of community, sharing different kind of information. And then at some point later today, you might meet up with that person and you might share information from two different experiences, thereby fusing the communities created by two different sets of information. This is a very dynamic process. If we repeat this often, we end up producing what is known as culture. And we end up producing cohesive communities just because we share information. The sharing of information precedes the sharing of resources, because we first generally have to talk about stuff before we share it. Right? We have to tell people where the water is before they can go get the water. And so that's a really compelling dynamic, and the intrinsic motivation to do so is called relatedness. It produces this, it responds to the psychological need of being related to each other. I find that tremendously exciting, and I hope that this kind of motivation will allow us to deal with things such as climate change more effectively, because climate change is not something we can solve through competition, but also through cooperation, just like in the BiD Lab. Now, when I did my sabbatical in the BiD Lab, I worked on this character here. This is Clouding McPufferson. Clouding McPufferson is the monster of pollution. And the first sketch of it was made at the BiD Lab. The first prototype for it was made at the BiD Lab. And the idea was that each of these eyes, if these eyes would light up in proportion to the concentration of pollutants in the air, and the monster of pollution looks happier and happier as pollution increases, and we're feeding this monster, making this monster happy. This is a reversal of climate change as being something negative, right? So there's now a positive hero who's going to win if we keep feeding the monster. It was designed for high school students. They participated in intrinsically motivated learning projects where where they had to go discover these sensors and go measure stuff out in the world. They didn't even know what they were doing at first. They gradually discovered that this thing responds to things. They increased their sense of relatedness to the world because they had data about the world. That eventually, in this period of 6 weeks, went from them having no idea about air quality to presenting graphs to their principal showing that their classrooms were the most polluted sites within South Central Los Angeles, and that they needed windows in their classrooms in order to ventilate. Probably we need a window here too, at least it should be open. It's been a while. Anyway, so the transition from total ignorance to actually becoming an advocate for change in your environment, it means a tremendous gain in autonomy. This tremendous gain in autonomy is again one of these things that grow out of intrinsic motivation. This project didn't stop, and we could just recently announce that the company that came out of this project, Acoma, now is installed its sensors, the pixel right there explaining that, on Google Street View. So we now will have air quality maps associated with Google Street View, and they will give us at least a partial sense of what kind of environment we live in, and maybe what kind of things cause pollution, and how we can gain some sort of autonomy in controlling pollution through our actions. So in a nutshell, that is what I learned from BiD, but I get to keep applying that together with Pablo Paredes. We're working right now on measuring pedestrian activity in cities. Pedestrians are the most vulnerable participants in the urban metabolism, and they are not protected by any kinds of machines, yet we know the least about them because we don't track where they are. We track where cars are all the time, the number of people. And so we'd like to come up with this metric of person per square meter per second, and we'd like to be able to light up their path in the night as they walk through cities that are perhaps dark and scary, and make them more comfortable. There's a lot of exciting research in this area. And of course, one big challenge is you can't just film people walking around, so instead of filming them, we're using these IR devices that just tell us the temperature of a warm body, and therefore preserve the privacy of the person. So what else did I learn? Well, I learned that you can bring people together by making events that are technically supported, and so it totally shifted my art practice. And the next project we're doing is recasting this Tsar bell. The Tsar bell is a technology project from 1735. It was meant to be the biggest bell ever cast, and it was cast by Tsarina Anna after Tsar Peter the Great made the largest bell up to date. She said, okay, we have to make one that's even bigger. So this one ended up being 600 tons heavy, and it was so heavy that at the time they couldn't pull it out of the pit they cast it in. So this was design gone out of control. And later on there was a fire in Moscow, very tragic, and they tried to cool off the bell because it was picking up heat from the environment being in flames. And they tried to cool it off, and as they did, they actually poured water on it, and that produced this big crack. And so by the time in 1835, when they finally had the technology to pull the bell out of the pit, they discovered the bell was cracked and it never rang. Sad story. It still sits on the Kremlin. It never rang. Nobody knows what it sounds like. But with finite element modeling, we can measure the piece and we can put it together and figure out what it sounded like. And so for the Cal Day on April 15th, I believe, or 18th of this coming year, we're going to put a recreation of the Tsar bell in this space here, where right in front of the bell tower. And it's going to be the same size as the original bell, except it's going to be made out of speakers that are going to reproduce the sound that we synthetically calculated. And so we finally will hear what that bell might have sounded like. And we will also be able to reflect on the notion that competition, especially extrinsically rewarded competition, sometimes can carry us too far and can help us produce systems and realities that are not intrinsically sustainable and that therefore fail. And maybe we can reflect on that and sort of, I think you mentioned something about humility and humbly say, well, what can we do together that actually will work? That's maybe not as competitive as it could be, but more sustainable. So those are the many things I can draw from my half year at BiD, and I just want to thank you all for making that possible, and I hope that in the future this climate of cooperation can continue inspiring many people. Thank you very much. So I'm the last speaker, so any questions? Happy to answer them. Otherwise, I don't know what happens next.
So, well, we sort of dispersed to different locations, but we have a bunch of posters mostly in the lab. I guess one thing to ask is if we wanted to, ideally all of you on there to give a short update. And we've scheduled that from 5 to 6, but if anyone has a conflict with that, we can maybe do it now. Otherwise we'll go and do the posters because the students will be waiting for us. Yeah, there is. Oh, well, there's two different things. There's the big group, BiD lab research is in the lab, and then there are concurrently several design courses. So there's design open there. They're listed separately on the schedule. There might be some extra copies of that on the store. But yeah, there's a nice mixture of things. All right, so maybe we'll head over there. And, if you see any trash or clean up on that way, I'd have to.
John, I'm happy to do 5 or 10 minutes.
Yeah, so I did.
Because it turns out that
One of the things that we call out